What happens when we create machines that are as or more intelligent than we are? What are the possible timelines, implications, and ways forward to ensure we create the most positive future for our world? This is the AGI Show, and I'm your host, Sarush Bor. Stephen Casper, or Cass for short, is our guest today. Cass is a PhD student at MIT in the computer science department in the Algorithmic Alignment Group, advised by Dylan Hadfield-Menell. Formerly, Cass worked in the Harvard Kreiman Lab and at the Center for Human-Compatible AI at Berkeley. His work focuses on better understanding the internal workings of AI models, better known as interpretability, making them robust to various kinds of adversarial attacks, as well as calling out the current technical and policy gaps when it comes to making sure our future with AI goes well. He's particularly interested in finding automated ways of finding and fixing flaws in how deep neural nets handle human-interpretable concepts. So, you've got all these human ideas. It's not so easy to code them up in any sort of computer system, and certainly not easy in a black box deep learning system either. And so Cass works on that. So Cass and I actually worked together last year on a automated red teaming paper, and we found an automated, scalable way to break the safeguards of a lot of the state-of-the-art LLMs at the time. So GPT-4, Claude 2, Llama 2, and have those models be able to be used for all kinds of terrible use cases. So everything from bomb making to cooking up illegal drugs to getting advice and support on running disinformation campaigns. So stuff that definitely these organizations who make them ostensibly don't want us to be able to do. And we did that as a way to show that these safeguards are far from robust and need a lot more work to actually prevent people from using them in these ways, especially as they keep getting better and better at whatever thing you point them at, including these terrible use cases. It was through that research that I learned just how knowledgeable and thoughtful Cass was, thinking through practical, impactful, and scalable solutions to these problems. And I think he's doing incredible work today, and really excited for him to kind of share that with us here on the show today. So without further ado, it's great to have you on the show, Cass, and I'm excited to kind of share more about your fantastic research with the world.
Yeah, thanks. It's always good to talk to you, Suresh.
Awesome. Well, I think we'll just start with Cass. It would be great if you could just tell us a little bit about you and your work in the AI field. So tell us a little bit about yourself and your work in the AI field.
Yeah, sure thing. So I think, I'm not sure if this is the case with everyone, but it's definitely the case with me. But I think my ongoing description of how I describe my work, it usually changes like on a monthly basis or maybe every few months. But what I say most recently or lately is that I work on the technical side of tooling for evaluations. And every once in a while, I do some work involving robustness. So most of my work can be summed up by finding problems with AI systems and sometimes fixing them.
Seems to be a bit of a trend in the whole field, unfortunately.
Yeah. I think more detail is good. So some of the things that I've been working on and thinking a lot about recently, we'll get a chance to talk about latent adversarial training. That's a big thing that I think is kind of neglected and that I'm pretty excited about. And I'm really interested in these types of techniques for finding flaws in AI systems, trying to come up with what bad behaviors they have, but also what bad kind of capabilities they might have. There's a little bit of a distinction there, but both are pretty useful for thinking about safety. I'm also pretty interested in seeing how they can be fixed with some of these methods. That's, I would say, like one of the things that's probably been taking up most of my thought recently.
Nice. So finding and fixing problems with AI models at the highest level, and then we'll go deeper into some of these concrete research areas you're working on. So, Cass, it's always interesting to hear how people got into this field. So I'd love to understand like what brought you into AI, what brought you into AI safety?
Yeah, I think it's a pretty good question. And it's one that's actually kind of like interesting for me to even think about like how to answer. I think the short answer for me is that in 2018, I read the book Superintelligence by Nick Bostrom, and I became very quickly convinced that AI was going to be very impactful and that it would probably be more useful and important for me to work on AI than what I was planning on at the time, which was biology work. And I actually think that, if in a different world where I wasn't concerned about AI risks, I really wouldn't be working on AI. I might have, been slightly better like cut out, or my personality or what I enjoy might have been a little bit better of a fit for actually just continuing to kind of pursue a career in biology. But definitely I think AI is where I like actually do truly belong. That said, I think my reasons for working on AI and safe and responsible AI has kind of changed since 2018. Like originally I was kind of motivated by what a lot of people were motivated by in the 2010s, the idea that, agentic super intelligent systems that we might not be able to understand and could hack through us like butter, and, with unknown levels of intelligence vastly greater than humans. I was worried about what types of these types of things really like taking over the world. And this could be the case. This could still happen. Like strange alien superintelligence could still take over the world. I ascribe a pretty significant probability to this. But I think my motivations and what I engage with over more recent years, like a lot of people, have included a lot of a much broader spectrum of different types of risks, right? I think it's really good to work on AI risk and risk management for all of the right reasons. Right. Even though I think my PDUM has gone a little bit down in the past few years, I don't think that really does much to get in the way of like the importance of working on AI going well for all of the right reasons.
Absolutely. And it's fascinating. Well, there's so many things. There's a few things I want to get into there. The first thing is I just want to say it's really interesting how similar our paths into this space have been. I also read superintelligence. I read it earlier and got into it later. So you had a faster reaction time than I did. Similarly read superintelligence. Similarly was working in biotech at the time. I read it. When I decided that I was going to switch into this field. So similar paths. And yeah, like you, I was convinced that there were some really big challenges, and also that this was probably going to be the most important trend of our century, and so probably made sense to work on. I find the piece about PDUM and still wanting to work in the field really interesting, because I've also had a similar experience. I don't think it's universal, but I think I've heard enough examples where people have gotten into AI safety, and after working on it for a long time, their PDUM has at least gone down. It rarely goes to zero, but usually goes down. And by the way, for anybody listening who's not in on the nomenclature, PDUM just means what are the odds you think that of all the things that could hurt humanity or cause our extinction, it will be caused by AI. And usually people mean in the next 100 years. They don't mean ever in the history into the future. So essentially our risk of AI causing human extinction. And so for both Cass and I, it seems like it may have gone down somewhat since we got into the field. So it'd be interesting to ask Cass, what do you think you've seen that has given you greater confidence in the future and greater belief that AI is not going to cause human extinction?
Yeah, I think that the model has changed. And what I mean by that is that, in the 2010s, or when I first started thinking about some of these things, it was before the like modern dynasty of state-of-the-art AI, that being like highly intelligent language models. Right? But before that, people, had a lot more uncertainties about how they expected AI to like play out, and what they really expected the paradigm to be. And for quite a while, I think the general notion was that the thing that might get us to artificial superintelligence, and probably this even traces back to like Alan Turing, kind of this idea of a system just kind of like learning from experience and social interaction and scratch from the world in a way that allows it to get very, very intelligent, kind of like a human gets very, very intelligent over the course of its development, right? People were kind of expecting that reinforcement learning was going to be the key to what gets us there. And, not everyone was really into this idea. Some people kind of detracted from it. There were people saying since a long time ago that like unsupervised learning was probably like the more the key to intelligence than anything else. But there kind of was this expectation that reinforcement learners, through interaction with the world, were one of the likely pathways to, highly intelligent, highly powerful, and potentially highly concerning AI systems. But I think that's changed, right? Because we still use reinforcement learning, don't get me wrong. But in the kind of the modern dynasty or the modern regime of like advanced AI, the key to it all, or like the bulk of what's going on, the bulk of the intelligence seems to come from pre-training data or, just reading the internet.
Lots
and
and
systems
lots of
like
data.
this,
Yeah.
systems like this talk and reason in ways that kind of make sense to humans. They're easy for humans to observe within a particular context. And it's not that these things are like solutions to alignment or safety or responsibility, but they're really helpful for being able to work with AI systems. They're quite a bit less alien, potentially, than people, certainly I would have maybe expected them to be, an expectation when I first got into AI. And that's a nice thing, right? Another thing that seems to be kind of good is that it seems most natural to create tool AI systems, at least ones that are deployed in very consequential applications, as opposed to like autonomous agents. And we still need to be very worried about autonomous agents, but it is a little bit encouraging that like AI systems just getting used as tools within the loop for some sort of process dictated by humans is the paradigm. This is nice.
Right.
Yeah. So I think a final reason that my PDOOM has gone down, but like not too low to not be concerned about, is that I've come over time, just as I think about things more, to expect that for many of the same reasons that it is hard for a human or a government or a corporation to take over much of the world, it's very likely to be very challenging for an AI system to do that, even if it has an advantage over lots of humans and that it's more intelligent in most areas, right? Our world is socially, politically, economically structured in a way that purposefully makes it very hard and naturally makes it very hard for individual actors to very rapidly, in a way that's hard to monitor, gain lots and lots of influence, right? So what I just kind of did is I just gave 3 arguments for why PDOOM should be low. But I want to like make sure that it doesn't come across as me saying the PDOOM is too low to care about. Concretely, like I try explicitly not to avoid this question. My PDOOM is something like 5 to 10%. I think there's a 5 to 10% chance that within this century, humanity could have its population reduced by more than 99% by a series of catastrophes triggered principally by AI systems, right? And the funny thing is that maybe like 5 or 10 times lower than a lot of other people who work on some of the same problems and work in some of the same communities that I do. But I don't actually think that makes a very big difference when you consider the decision problem, because extinction remains, or like catastrophic level risks remain kind of one of the dominant terms in the impact calculus in my case still.
Yep. Well, yeah, and we don't, as humans, generally have a good way to think a lot about kind of these kind of lower probability events. But at the end of the day, being a 10-sided dice or, a few coin flips away from humanity is gone is not where we want to be, and not something we should be headed towards in any way if we can avoid it. And this one is definitely avoidable. We're the ones creating it. It's not some comet hitting Earth. It's something we're building as a society. So definitely agree with you. I generally agree with most of what you said, and would add even other reasons for why the risks are potentially lower than I thought when I entered the field. The one I want to just go into a little bit is the question of tool and agent AIs. In my view, and tell me if you feel differently, agentic systems or autonomous agents are also economically very valuable. If we could have an assistant who could, book all of our appointments in a day, or be an employee, or be our domestic servant, or whatever, all the work that we want to be done for us in kind of like a fully autonomous way, we probably would. So do you think, do you kind of disagree that there isn't as strong of an economic incentive, or do you think it's purely a limitation technically that we haven't built these autonomous agents?
Well, I would certainly say it's not a technical limitation, right? it's not hard to design some sort of system that has the ability to like automatically post online or do things online. I kind of just described a bot, right? And there are bots all over the internet and all over our world.
Right.
So I don't think it's so much of a technical challenge, but I do think, and I do think this is a risk, right? I think that like lots of the probability mass or the conditional probability mass within my subjective expectations of how we could lose control of AI routes through some kind of scenario that involves a negligent or malicious actor deploying an agent on the internet who can do something like this, right? Especially if there are lots of copies of it, copies of this kind of thing. However, one thing, to defend what I said earlier about like it kind of being kind of encouraging that tools are more useful than agents. I do think that like tool type systems like chatbots, that can't post to the internet or aren't embodied by some sort of physical robot. These types of systems are useful are the right types of systems for most types of tasks, or at least most types of tasks that very broad user bases are going to want. For the type of people who would be interested, for terrorist or non-terrorist reasons, to deploy some type of agent that's embodied in the physical world or online. I just think that group is significantly smaller, and they would be ones with kind of much more niche preferences or like needs, right? It is very economically valuable to be able to have systems that automatically do things. But, lots of these are ones that still have kind of like action spaces that are limited enough that you can just, intuitively or formally or however you might want to approach it, guarantee that nothing bad can happen. If I have a system that can only read from the web or can only interact with a certain database, then for reasons that like people from the computer security literature could tell you are either trivial or tractable, we can guarantee that the system isn't going to cause problems, right?
Right.
I just think that the type of system that's going to be able to act more open-endedly in the world is probably going to be a more niche type of one.
Interesting. So you don't...
Still one that can happen, though. Right?
Oh, absolutely. And then, so you don't think, though, that in the somewhat nearish future, let's say in the next decade or two sort of time range, we will produce agents that people will find useful and therefore deploy lots of them, that also will have broad action spaces? That's not something you're kind of currently seeing as a likely outcome.
Oh, no, I think it's going to happen. I just think that like the base rate of it is probably not going to be huge. And, there are going to be lots of filters between instances of this and potential like catastrophic outcomes. Right. Yeah. I'll just sum it up. I'll leave it at that.
Yeah. Interesting. Yeah. I'm not sure I have quite the same hopes and views, but it's a really hard thing to think about, and definitely not something I feel confident on either that won't happen.
I think there's maybe an analogy here between, like the types of agentic systems with the action/option spaces that we should be worried about, and like slaughter bots, right? There's a lot of concern, like good concern, that these things that are called slaughter bots could quickly be made and used. So a slaughter bot typically refers to some kind of like drone or like small autonomous device that probably has like advanced controls and some decent vision system that can fly around, and the slaughter bot can like target people and could carry an explosive or a poison payload, right? So there's this really big concern that slaughter bots could be used for arbitrarily evil and bad things like assassinations, targeted harm against demographics of people, et cetera, right? And part of the reason we need to be so concerned about slaughter bots is that they can just be built. Like we have all the technology, humans have all the technology involving drones and vision and explosives to build slaughter bots a long time ago, right? It's not just that, a recent development a few months ago made this possible. But thankfully, we have not seen like slaughter bots causing chaos in the world, right? That's not to say that they won't, that they very likely will. But you have to ask, like, why haven't slaughter bots caused a bunch of chaos yet, even though they could have? And I think that's just because, thankfully, even though they are within humanity's capability to build, the set of people who could and would build slaughter bots, is actually a pretty small intersection.
And I guess, and those people are limited by laws, societal implications, ethics, like all of these things.
Yeah.
Yeah.
So,
yeah. And
can I actually say a little bit more?
Please. Just
in case you're going to change the subject. So one thing I've been kind of like thinking about or introspecting on in the course of talking about this is like, I might need to defend some statements that I've made that seem kind of like contradictory, right? I'm saying a bunch of different things. I'm saying I'm really concerned about catastrophic risk. I'm saying that catastrophic risk is not as likely as I used to think it was. And I also was saying earlier that AI systems, it's really important to make sure that AI goes well for all of the reasons. Yet I'm also saying that like catastrophic risks dominate my impact calculus. So like what's going on in my head? And I've actually felt kind of like weird in this conversation so far because I've been talking in terms that I almost never actually talk in, not that much these days anymore. It's kind of interesting to me. Like my brain caught myself saying stuff that using vocab and thinking in terms that I haven't thought of in a while. And it's true that I think that like catastrophic outcomes, when you do the expected value calculations are probably the dominant factor when thinking about like challenges with AI systems. But that kind of core belief of mine, like I think doesn't conflict, but does contrast with another really core belief of mine about how making AI go well is a very complex socio-technical problem. Right. I think one of the views that shapes my approach and my thinking for almost all of the AI work that I do and how I view the field is the idea that for AI to go better and not worse in the future, we probably want to pursue a future where there are lots of checks and balances against the power of AI systems and people wielding powerful AI systems, right? And in order to do so, like we need institutions, right? Not just technical solutions. And for that reason, reconciling near-termist and long-termist concerns about AI seems particularly important. Bringing together people in order to set up the institutions that will help us to handle AI seems particularly important. And I think this, in 2024, this type of viewpoint is a timely enough one that it kind of dominates a lot of the views and conversations that I share. The one that tries to bring people together because it's the right way to accomplish everyone's goals.
Yeah, and I think the good news is I think many people have been coming around to that view, which I would agree with, that making the future with AI goes well requires strong institutions. To get strong institutions, you need broad coalitions and broad political action and kind of coherent ideas about what the world wants. And so that's a worthwhile cause to be working towards. And thankfully there are many people working on this, and there could be more. That would be.
I think a quick shout out to like other different types of like research clusters and communities out there, because definitely, arguably, before talking about regulation and governance, went super mainstream within the kind of like AI safety and alignment communities. This thing was already mainstream in different communities as well, particularly ones focused on social justice, bias, and inequality, I think.
Absolutely. They've definitely been working on this for a whole lot longer than the more kind of X-risk focused community. Completely agree. So is it fair to say, just to come back to that question around kind of agentic systems, that, it's so interesting because I still wonder how much of the limit, the slaughter bots is a really interesting example of something that's technically possible and held back by institutional and ethical and kind of other practical limitations. Will that apply to what we're talking about with kind of broader agentic systems? So imagining today, because you're right that we can create bots today, and people do create bots. There are lots of them on the internet. But their bots are obviously with relatively limited capability. They're certainly not ones that reason like anywhere close to the way humans do, or to the extent that we can. So the imagination here is something like we create systems that can do that, but then they just don't become very commonplace, or not to the extent that they're the source of major risk. Yeah, I wonder how that will play out. I mean, I could definitely see technical limitations and practical limitations limiting how they are released. But I think as they get really good, we just have so many problems that would be economically valuable to solve with these agents that they will probably proliferate. Do you feel differently?
I think we're mostly on the same page, but I think about this a certain way, and in a certain weird way. So specifically thinking about, how things could go wrong in the future involving agentic AI systems kind of getting out of control, right? And, in which like a human is not in control anymore. It's the system that they deployed, which is calling the shots and wreaking havoc or something, right? Specifically thinking about this type of scenario, on one hand, there is this struggle that I have to think about what specific scenario would really make this happen. It's kind of difficult to imagine like what the person who, initially flips the switch and sets things off would be trying to do, what their motivations would be, what type of system they would have created, what type of action space that system has, what type of context that system was deployed in, and what that system does to get so much power and influence without being like shut down or stopped somewhere along the way by someone, right? It's really difficult for me to think of a concrete scenario in which something like this happens. But on the other hand, I have this very contrasting worry in which, I think that, there are lots of people with lots of goals, and then the future goes on for a long time, indefinitely, right? So it's, even though it seems hard for me to imagine any single instances of this happening, integrated over time, I think the possibility of this, seems to get very serious, right? And that's kind of these kind of two conflicting viewpoints, give me like a lot of uncertainty about like what could happen in, failure modes where catastrophic things happen because agentic AI systems are deployed in a way that causes the person who deployed them to lose control. However, and this is the big however, I don't actually think that's where really most of my P-doom comes from. I think most of my and this isn't like an out there view, but I think it's one that like puts me, I'm not quite in the middle here. I'm definitely on the, more worried of us side than the more worried of the bots side, right? But I think that a large proportion of the P2 or P catastrophe risk that we face, stems from misuse rather than, misalignment, or misuse of a tool maybe rather than misalignment of an agent. And even in a way that contrasts with how it's hard for me to imagine how an agentic system might wreak havoc on its own. It's very not hard for me to imagine how very, very bad chains of events could be triggered by particular bad actors, right? Imagine today's worst dictators or worst like heads of state or worst, most powerful people.
Yep.
And imagine what they would do if they had access to like swarms of millions of of slaughter bots, or if they had access to some other comparably powerful AI system. Right? Mm-hmm. It's kind of difficult.
And some of this we're seeing, right? We're seeing unprecedented levels of drone usage. So we're seeing some of this at least starting.
Harvard drones are being deployed in Gaza, which are capable of making autonomous decisions to kill without meaningful human oversight, right? There's precedent here. But in like 20 years, it's kind of difficult to imagine this not being within the capabilities of some despotic head of state or something like this, right? And this type of event would not be an existential catastrophe in and of itself. There probably will not be like 10 billion slaughter bots flying around at any given point in time. But this could be the type of event that causes profound destabilization, right? Our world was rocked to its core by coronavirus and everything that did to, supply chains and the medical industry and, downstream of that, the economy and everyone's daily lives all of the time, right? Imagine the types of bad things that could be triggered by millions of like bots, like slaughter bots or something like this. And, as our community gets, our global community gets more integrated, I think it also is going to become more fragile in some ways. And I guess that's not like a novel take to me. That's kind of what everyone, a common understanding. But
yeah, I think you.
This is where I sort of expect a lot of my, where I think a lot of the risk that I expect comes from.
Yeah, and I think we've touched on a lot, so I just want to kind of try to pull that a bit together. So, yeah, we first started on kind of talking about, well, how realistic or probable, or how can we imagine this situation where a agentic system, accrues so much power that it itself is the source of the catastrophe. Then we kind of moved into misuse scenarios and how they seem to be potentially a greater source of risk. I want to dig into that because that's something that definitely kind of differentiates the view here from the view of a lot of people in the kind of existential risk community, particularly those who have spent a lot of time trying to come up with technical solutions. So I want to dig into that first part, firstly, of like, how realistic is it for a system to kind of accrue power on its own? I think it is definitely something that's harder to imagine in the concrete. And I think this is why you don't see as many concrete scenarios. Even, superintelligence kind of talks about this in somewhat kind of high level terms of intelligence goes up, capabilities go up, and humans are helpless to stop it type kind of analogies. It feels like there are some vectors where something that was very capable without even accruing lots of power could cause, catastrophe or something close to. Things like creating a single bioweapon, a novel pathogen and releasing it in the world, or something like, hacking into a nuclear system and kind of deploying nuclear systems. So you could imagine something with very powerful capabilities on just one or two dimensions, whether it be cyber or bioweapons, potentially wreaking havoc in the world. So it does seem, some of those do seem plausible, but those things can also be triggered by human actors and then by misuse actors. And I guess this is where some of the misalignment and misuse blurs together. And you can even imagine it's a combination of things. Like you've got this system that has this capability. Someone does something, maybe they even want to cause a little bit of damage, but maybe not the level of damage that they expected. And it's those outcomes that are really problematic.
Yeah, absolutely. I think my major thought here, I think we're on the same page. And I think something I think about a lot here is how there's this like useful but very false dichotomy between misuse and misalignment, right? And I deal in terms of this dichotomy all the time. I just was a few minutes ago, right? But it's not a dichotomy, right? There's this like spectrum of negligence in between misuse and misalignment. And I think it's important to appreciate this. And I also think understanding this spectrum is also a good way to understand different clusters of people inside the AI safety community. Right. I think if you were to, take different researchers and personalities in the AI safety space and represent them in some appropriate space and then run principal component analysis on them, on their ideology, so represented, I think that one of the first couple of principal components would probably correspond to something like how afraid people are of misuse, things that are more on the misuse side versus things that are more on the misalignment side. I think if you're very worried about misalignment, if you're very worried about scenarios in the future in which some smart and well-intentioned creator of an AI system despite their intelligence and well-intentions, loses control over it. If you're worried about this kind of thing, you're very likely you're working at like Anthropic or OpenAI, or you're very sympathetic to the missions of like these companies, right? And that actually, I think, explains a lot of, the rhetoric and the philosophy behind, lots of the corporate AI safety agenda, right? Whereas if you're more worried, if you don't think the fault's in our stars, or if you think the fault's in ourselves, or you're more worried about, how humans might, who are either like not benevolent or not, fully understanding of what they're doing, could cause bad things to happen with AI systems. That might be a sign that then you're more worried about like the socio-technical problem than the technical problem, right? And for people who strongly emphasize this, I think lots of them are in government or in advocacy or in academia, right?
Right.
And maybe there's kind of like that cluster of motivations and that non-corporate type of agenda on the other side of things. And I find this clarifying. This is one way I kind of understand and try to make sense of, the communities in the world around me.
I definitely think it's interesting to look at kind of who's concerned with what. But I also, to some degree want to, and maybe this is just my own kind of the way I kind of interact with the world, like want to put that aside, at least for now, like at least for the question of where is the risk actually? And then of course there's a separate question of like, well, how do you address the risk that you believe exists in the world? But like to the extent that, because to the extent that people in these, say the companies care a lot about this misalignment type risk, I don't think they are doing that because it is good for the company. I don't think so. For the most part, they're doing it because they read superintelligence and because they genuinely believe that this is a real risk and that it can happen. So I know that there are definitely people with different kind of views, but I'm less concerned about who's got what views and more concerned right now, at least in my head, about what is the actual risk and therefore what is the response we should be putting in place given those risks.
Yeah, I agree. I think this is a good and important point. And I don't have anything to refute about it. I would add a little bit though. I think I don't particularly, or maybe I do. I don't emphatically distrust like OpenAI, AI, and Anthropic, right? I think these organizations, more likely than not, will not do anything particularly malicious that triggers anything bad, directly triggers anything bad, right?
Yep.
It could happen, right? These systems these companies are complex systems that are not monolithic, and there are lots of individual and corporate incentives going on. And companies face their own alignment problem. Right?
Yes.
And there are lots of ways which you can pretty easily view like AI companies as themselves being misaligned or showing signs of misalignment. However, I'm still not actually that worried that Anthropic or OpenAI or other similar companies are going to do something directly bad. What I'm more worried about is kind of like the race toward the proliferation and the race toward AI capabilities and how this is going to spread. Historically, humanity has not done a great job, across sectors, different institutions, whatever you have it, like of developing some technology in isolation and then just making sure only the people who develop it have it, right? This stuff can sometimes last for years, like with nuclear bombs, right? The US was ahead by years, but that only mattered for I think probably less than a decade until other countries, also developed their own nuclear weapons. And then we had the Cold War, which was geopolitically not great, right? In AI, I think everything seems much tighter. Those pushing at the state of the art, usually OpenAI, tend to be between 6 months and a year ahead of other competitors, and a little bit more, but not like more than 2 years ahead of like the open source community, right? So I think it's this view. It's the proliferation-centric view that I think is the best type of argument behind views related to kind of pausing or slowing down AI being useful, right? I don't think it's directly like we need to pause or slow down. I don't think the argument about pausing or slowing down AI for the sake of directly, limiting OpenAI or Anthropic's capabilities is the more compelling one. I think the more compelling one is to like put a damper on the overall proliferation of what's going on.
And I think that, and I suspect that possibly what differentiates your view there with some of the people who are more concerned about the OpenAI Anthropic is where they think the risks come from. And I think one kind of takeaway I'm getting from this conversation is like, do the risks come from the agents, so the AI's intent, like the AI's goals, which is more of a misalignment type problem? Or do the risks just come from the capabilities being available at all? Like there is such a system that can cause great havoc, whether in the hands of an AI system or a human, or a structural risk of an interplay of those things. And I do think I'm definitely more sympathetic to the view after this conversation that the risks actually come from the capabilities existing at all, and the fact that they exist in our world, just like nuclear weapons pose us some risk, or other kind of really catastrophic risk factors pose us risk, regardless of who invents it and how quickly they fall into the hands of different people.
Yeah, I think that's cool. I think I generally, think in these kind of terms too. But, as probably this is becoming relatively clear, I have a lot of vague thoughts about a lot of vague ways things can go wrong. And just speaking for myself.
Yes.
I think that, summing over all the different threat models creates this like very muddy picture, and things add up, like I said earlier, between, 5 and 10% of something extinction level happening this century. And it's all very confusing. Right.
I agree. I definitely get a strong agree on that one.
Which helps me come back to like the kind of key principle that I think guides like lots of what I think about and care about recently. The idea that, probably the best way to mitigate large scale risks from AI in the coming future is going to be to solve institutional problems and have lots of checks and balances against AI systems and people who use them, the powerful ones at least. And having the institutions that are capable of doing that, kind of like I was saying earlier, I think is best achieved by reconciling differing viewpoints about why AI is scary and getting together and figuring out how to potently govern it. And I actually think that the technical challenges, I'm not solving all of them, but they will probably will be solved, most of them, if they there might not even be any large scale key technical challenges left to solve.
It could be lots of little things, or it could be already solved. We just don't know.
Yeah. But I think long term, like long haul with AI safety in the perpetual future, the key is going to be institutional, cultural, and political problems.
Interesting. No, and I think it's a really good viewpoint for lots of people to hear, because I definitely agree with you that I don't see any futures that go really well without some really good institutions. Like I think that's a necessary, I'm not sure sufficient, but definitely necessary condition for really positive futures, having those really high quality institutions. The other takeaway that I've had from this conversation is something like, there are these different risks, and they may present, and they may be the kind of most elevated risk at different points in the kind of trajectory of this technology. So maybe in the next bit of time, maybe the next decade, something like that, these capabilities continue to grow, especially in tool-based systems, and that poses a lot of risk. I could imagine, and I don't think I need to stretch too hard to imagine, in a longer time frame, if we do start to create some amount of autonomous agents, and the costs of those systems keep going down and they're cheaper to run, that they start to become actually just part of society. And I don't mean part of society as tools, but part of society as characters, as like people, like persons in our world. And in that scenario, I find it easy to imagine how those things could accrue power, start to establish their own kind of segment of society, take power, that center. And I'm not sure how quickly that will happen. Is that like something I'm talking about over decades and centuries, or am I talking about that over years?
Yeah.
I'm genuinely not sure. But it's more viable to me to imagine that future in the kind of longer range future. And a longer range for me is more like decades, not centuries.
Yeah. What you bring up makes me think a little bit about analogies to the internet. And I don't claim to be particularly thoughtful, but I'll say stuff anyway here. Right. But I think an interesting question to ask is like, regarding the questions you're asking here, what can be learned from the internet, or what hypothetical scenarios involving the internet can we think of, right? Because the internet is this very powerful, globally integrated thing that is governed somewhat, but also still quite fundamentally uncontrollable, right? These are all strong points of analogy with what we might expect powerful AI systems to become, right? And there's some nice things about this analogy. Like working on AI safety now might be a lot like working on internet safety, or right as the internet was kind of beginning. And the same thing with policy, right?
Yep.
And it would have been great to have more of that earlier, so it's good we have that now. But the central thing about the internet that I'm thinking of right now in response to what you're saying is that the internet can enable a lot of bad things, right?
Yep.
Just bad things on the internet. It can help people order stuff to make bombs or bioweapons, right? That's certainly way easier today than it was before the internet, in an analogous way to how we expect certain malicious things to be way easier in the age of AI compared to before the internet, right? So like, is AI going to make things easier on top of how easy the internet already makes a lot of things, but is it going to make it too easy? Is it going to, is some kind of threshold going to be passed in which, we run the risk of lots of destabilization? And another thing is like the internet kind of matured over years, right? We might have comparable, or we might not have comparable timelines with which AI tech and its integration with society matures. And whether we do or don't, like, does that make a really big difference in like PDOOM, right? Does that make a really big difference in how likely it is for things to go bad? I think it's quite plausible to think that maybe if the internet happened all at once, or if the internet today just kind of was thrust onto the world in the 90s, that like a lot of crazy shit would have happened.
And it did happen It did happen pretty quickly. I mean, look, I don't think either of us are all that old, and it did happen within our short lifetimes.
So anyway, I don't think I'm saying anything too profound here,
too
and I'm not really giving any takes. I'm just I have thought about this before, and I think it is a useful like anchor to think about questions of like how the way AI is integrated into society affects things, and how fast the takeoffs and the integration really are, and how that affects things. And quite possibly, I think these things like it's like slow takeoff could be very good.
Absolutely.
Because it can allow for more societal and political adaptation.
And
that, by the way, is like why I think that like, slowing things down, pausing things,
right.
in as much as that's possible, that is also great, because policy moves much, much more slowly than technical progress.
Right. Yeah. And thankfully, even without the policy so far from a more kind of like technology path perspective, it does seem like we're seeming to get more incremental milestones rather than just, this kind of like fast takeoff. We're seeing systems that are subhuman and subhuman and sub, like kind of seeing those incremental steps. And I don't want to measure just against humans, because I think these systems are fundamentally different, but ultimately it does seem like we're getting something more incremental. And that is actually a really good thing, because people go, "Oh, ChatGPT. I mean, it can't take over the world, but it does look pretty powerful. Like, what could it do?" And it kind of forces lawmakers and average people and ML researchers to kind of take the questions more seriously at each step of the process.
Yeah. Something I talk about a lot is how I love it when modern AI systems fail egregiously. And you already knew this about me, but like I mean this in the truest, like the most serious, true possible sense, right?
Yeah.
So right now we have the regime of advanced AI systems is like GPT-4 level chatbots, or these general purpose, quite intelligent, arguably generally intelligent AI assistants.
Yeah.
Right. And it's bad when they fail, right? They can spread misinformation. They can help people with bad tasks. They can, encourage people to do bad things, right? But if this is as bad as things ever got, if the greatest AI system, risks from AI systems that we would ever face are the same as the ones that we're already facing today, then that's pretty nice, actually. Like, many of us, if that were the case, if we found out we could just breathe a sigh of relief and go and work on something else, I would probably go figure out how to do biology again. Right?
Yeah, I go probably use AI for positive ends. I go see what AI could do for climate change or biotech or pharma or something.
Yeah, it could pick a different cause area. I should work. Maybe I should work on bed nets at that point, right? But we don't expect the biggest challenges are going to be from the types of ones that we're experiencing with today's regime of in the state of the art right now. We expect them to be much greater. So that's why I think it's really good when we see as many failures as possible right now, right? Because it's a bad sign, but it's a good thing when we see more and more failures, because we get more information about the risks that we didn't anticipate, and we get more experience and opportunities to work on solving problems that we're going to face analogs of down the road. Right?
Yeah.
So this is something that is a little bit counterintuitive until you think about it enough. But for this reason, I am very anti-filter on ChatGPT and stuff. Right? Have you noticed how the AI, most of the AI chatbot interfaces online, will stop generating when they see something bad, or they will sometimes regenerate things, or there's some filters in place that are trying to prevent the worst things. And these are well motivated. I think these make sense, and these are in companies' interests to do. But I think somewhat counterintuitively, we should ideally we would have none of these. We would have users interacting with the system with as few barriers with the model, not the system, but the model inside of the system, with as few barriers as possible, so that we can get as much feedback as we can about what these models are doing. Because filters are an easy layer of Swiss cheese, right? They are an easy defense that can not just 80-20, they can 99 or 98-2, lots of the problem here. A lot of the time, not necessarily in front of an adversary, but in front of in front of benign interactions. But for that reason, I think that it would be great to have more, barefaced instances of the chat bots failing that, pop up on social media and, garner a bunch of attention, just so that we could better understand things right now.
Yeah. Yeah. I mean, I guess my only pushback on that is I do think that those filters are part of the controls that we're, part of the safeguards that we can apply to make these systems safer and better. And so we should also be learning about them, and we should also be figuring out what the failures are with those in place, not only with them removed. I do think researchers or some subset of people should definitely be poking holes at the base models too.
Yeah, I 100% agree. I think the right synthesis here is that in system safety engineering, it is important to test system components individually, but also test them together. You
Right.
want both, right?
Yes.
But you'll probably but you're going to find more flaws when you don't have redundant safeguards, when you're doing tests of components.
Right. You'll find out how the component can break.
Yep.
So this feels like a really good transition point, Cass, into digging more into the technical side of your work. And I did love this, by the way. That was fun to kind of explore that risk landscape and get deeper on it and get your views, because I learned a lot from that. So, but yeah, now I want to kind of dig more into the more technical side of your work. You've worked in a lot of different areas within AI safety. Maybe tell us a little bit about I mean, let's just do a little bit of a broad landscape first. Again, what are some of the technical areas, or what are the areas of AI safety that you've worked in?
Yeah, I have done a few random things, right? And I actually have this like kind of confusing identity as an AI researcher, right? I have a technical background and I primarily do technical work, but I'm convinced that the main safety problem is an institutional one. So what do I do, right? I think long-term, my best bet is to be like a policy relevant or technical person, or someone who tries to do useful work. So useful technical work that can influence like policy and culture. I'm also an academic, which means that I don't have access to state-of-the-art models or state-of-the-art computing clusters.
Right.
So there's lots of technical work that I shouldn't do because it's not my comparative advantage, right? And that combined with just interests that have, all of that combined with interests that have just kind of like changed a bit in the past few years has just like led to me working on a set of things that are not the most harmonious, but I don't know, I think it's still getting fun. So in the past, I have worked a lot on things related to interpreting models. A little bit of interpreting individual components of models, but a lot of concept-based interpretability of models, where through some black box or non-black box technique, you try to infer useful properties of the model from working with it with different techniques. Very recently, I've been focused, or not very recently, actually, for a while, I've been focused on adversarial attacks and worst-case vulnerabilities in AI systems. But more recently, I've been focused on doing like adversarial training and adversarial testing involving like large language models, as you know about, because we worked on that type of stuff together.
Yes.
And I actually think, and something that I find is really interesting is the more I work on, the more I find out that everything I work on is actually kind of the same. Right? So it's all kind of like part of a model internals a super agenda or a cluster of agendas, right? It's kind of wild that like most of the technical topics that are being worked on in AI just involve something or other with model internals, like mechanistic interpretability or mechanistic/latent adversarial training or mechanistic anomaly detection or nascent attempts at frameworks for formal verification of AI systems. These are all different types of model internals based answers to this black box problem, this fundamental black box problem.
Right, just the fact that we want to understand what is going on inside the systems. We want to be able to go, you made this decision, where did that come from? Because if we could modify that, we could prevent that, we could do lots of interesting things with it. Yeah. And so why don't we start with the interp area? I'd be curious to understand, a couple of things. Maybe let's start with the state of interp. Like, where do you think we're at with interp? What do you think we've achieved, and what do you think is left to achieve when it comes to interpretability of the current models?
Yeah, I think this is going to be an easier question to answer in 6 months, but we'll see.
Sure.
So interpretability has been something like mechanistic interpretability specifically, right? Attempts to understand and make sense of the internal workings of advanced AI systems. This has arguably been very popular, and at least within the AI safety kind of community and space, since maybe 2015 or 2016, right? There's been a lot of work on it in the past. And for the past few years, so for a while, I worked a lot on interpretability directly, like including some mechanistic interpretability stuff. And then for the past few years, I've become somewhat of a critic of interpretability. Sometimes people describe me as an interp person, and I'm like, am I an interp person? Maybe. But I do think interpretability is a really interesting field because there's a large amount of excitement and potential and work and money being spent on it. But I've expressed in the past a lot how I think that this is not commensurate with what types of things interpretability has kind of achieved as a field. Where the thesis that I kind of have talked about for a few years now is that interpretability tools are just or mechanistic interpretability tools just do not tend to be competitive solutions to the types of problems that we might hope to apply them on in the real world, right? So I've been a little bit of an interpretability boogeyman who always just tries to make sure to be critical, not because I think it's bad, but because I think that interpretability benefits from a lot of scrutiny. And I think that, now we are in this potentially hingy time in which, interpretability research is starting to show signs of becoming, of having a paradigm that's less based on kind of eye tests or researcher intuition or just looking at things and being like, oh yeah, I interpreted that, I understand it now, and starting to be more applied to problems. I think there's been some interesting work, and most of it's been in the past few months, right? That have applied mechanistic interpretability tools to demonstrate proofs of concept for solving useful types of tasks, right? I hope this continues. And I hope before too long, it leads to interpretability tools being applied competitively for non-toy tasks, for real world problems.
What are some of the things you've seen in the last few months? Like what are the kinds of really interesting kind of, here's something it was applied to where you saw some real promise there?
Yeah. So my favorite recent example of this is a paper from Sam Marks is the first author.
Okay.
And Sam is a friend. And I think this is a great paper. This paper is kind of part of recent work involving sparse autoencoders. And this paper, I could find the title. I'm forgetting the title, but forgive me. Actually, here
we'll put it in the show links anyway, so people will definitely be able to find it.
Okay, great. So this paper used sparse autoencoders and worked with them to do a type of task that I think is really good. And it was a toy instance, but it was really nice. So what they did is they had a data set, and this data set consisted of binary labeled examples. One class of examples consisted of textual descriptions of female nurses, and the other class consisted of textual descriptions of male professors, right? A text classifier was trained to distinguish these two types of examples. As you might imagine, it was pretty easy to train it to do very well, right? A sparse autoencoder was then trained in order to understand, or helped start to understand, one of the layers inside of this transformer-based classifier, right? And then manually, the team, what they did is they looked at the features inside of the sparse autoencoder that were like salient for this type of classification problem. And they were able to manually label most of them as picking up on the female feature, and some of them as picking up on the nurse feature. Or, female versus male and nurse versus professor, right? And then they were like, okay, is this understanding valid? Can we put it to the test? Can we do something useful? They went ahead and ablated those sparse autoencoder features that seemed to be sensitive to gender. And they found that the resulting model with those ablations was no longer gender biased, right? So this, taking a step back, super toy, right? I'm not surprised this worked. But I actually didn't think of this idea myself. And I'm glad that they did it. I think this was despite how simple this was like a very, very smart and genius approach to this kind of thing. And something that Interp research really needs, because this is the type of problem we'd certainly hope that mechanistic interpretability can help us solve, right?
Why was it so novel? I mean, it seems like, I guess one thing is that sparse autoencoders are relatively new. So there's obviously not been, years of work on them, but nobody else has tried these kind of ablation studies with some SAEs, or is it just that no one's tried it on a more like practical, relevant example?
Yeah, you bring up this good point. And, there are a few ways to answer it. But part of the key understanding here is that there's a very continuous spectrum between things that are like super toy and useless versus things that are super realistic, right? And, past work has fallen on this spectrum a lot. And no, there are definitely examples of past work that have done useful proofs of concept with mechanistic or concept level interpretability tools. I have made various lists of these different things at different points in time. And, if someone wants to email me, we can toss papers. I can toss papers to them if they're particularly interested in stuff like this. But what I think was kind of good about this paper is it's this contemporary example of doing something in a transformer that is accomplishing a sensible type of task. And the key thing here, though, is that it did something more than just creating a hypothesis that seems about right, right? This paper, by ablating the sparse autoencoder features, was able to kind of prove or demonstrate that their hypothesis about what was going on was good enough to guide a useful type of an edit to a model. Not a useful instance, because this is a toy problem, but a useful type of edit to a model. I think I have found it surprising in the past to do a lot of review and a lot of knowledge systemization and past interpretability research, where the standard to judge interpretability techniques by is not one that is based on using the tool in a downstream task, right? It's based on producing explanations that seem lucid or interpretable to a human, or just kind of passing an eye test, or producing some kind of explanation that gets someone to nod their head to it. For example, so there's some classic examples of this. There's early work on feature visualization, claims to understand neurons by optimizing inputs to visual classifiers that activated particular neurons, and then having humans look at those visualizations and say, oh yeah, that looks like a dog, or that looks like a cat, or that looks like a pool table. Right.
Or the part of the dog, or the snout, or whatever it was.
Yeah. And this, I think possibly our early work like this set a little bit of a paradigm. And I'm not drawing things back to any individual paper. I think this problem has actually been pretty pervasive,
and maybe
in multiple fields.
It feels like it was probably an important step in the process. It's just maybe got stuck there for a little long.
I'd say yeah. I think this is part of the scientific process. It's part of investigating things, but interpretability is just this hard field to work in because in most other fields there are more concrete benchmarks or there are concrete measures of success. But the reason so many people care about interpretability is because, of what can happen when you really do understand the model really well. What could hypothetically happen? But it's just that's such a lofty goal, right? So we kind of try to shape the signal we work from here by having these different expectations. And I think it's pretty natural to, do a lot of early interpretability work that is meant to pass eye tests, right? Or that is meant to seem plausible. But I do think at the same time, the interpretability field has gotten has an interesting paradigm and has gotten kind of stuck by it because there's quite a lot of work that focuses on producing methods that make researchers think or be able to hypothesize plausible explanations for what's going on. Yeah. And even worse, sometimes that's cherry picked.
Right. And some of those plausible explanations just are not correct. If they could just be spurious correlations, unless there's some sort of ability for those things to predict some other, be generalizable to other situations where there's some semantic meaning or something, that you could just be catching a correlation rather than actually coming up with a fundamental explanation of what's going on.
Yeah. And I think things get even a little bit more insidious than that. So far I've been talking at a pretty high level. I think it'll be useful for me to try to maybe talk at a more specific level.
Yeah.
So lots of what people are excited about, and maybe have always been excited about, but with interpretability, has been methods that can be described as attribution methods that are meant to attribute a specific model behavior or output or whatever you may to a set of features, or maybe not, more generally to a set of objects, right? There are different feature attribution or feature saliency methods that try to attribute decisions to input features. And there are lots of other attribution methods, which are sometimes called circuit discovery methods, that are meant to attribute specific model behaviors to internal circuitry, like weights and neurons inside of the model,
yep.
Right? Or even more generally, even influence pathways inside of the model. And lots of this is very, very popular in current, state-of-the-art mechanistic interpretability research. I know you've heard about, and probably most other people listening at this point have probably heard about automated circuit discovery methods, or activation patching or causal scrubbing, or localization methods inside of AI systems, right? This is kind of like very central to the state of the art in mechanistic interpretability research, or at least circuits-based mechanistic interpretability research, right? And they're all attribution techniques. And I think throughout the history of interpretability research, there has been something that I'm starting to call the attribution cycle, or the attribution research cycle, where an attribution method gets proposed and it is, eminently well justified and formulated. It produces some plausible results. Things get cherry picked, they get presented, papers get written, and it seems as if progress has been made. And then people find a bunch that the attribution method fails a bunch of sanity checks or does not prove to be useful in downstream use cases.
Right.
And this gets observed. Someone points out the problem in how the attribution method was developed, and they develop a new attribution method. And I think this describes a lot of failures. I think this describes reasons why classical feature attribution methods like LIME and SHAP are still useless. I think this describes why neural feature visualization loses to looking at real-world exemplars when it comes to predicting neural activity patterns. That there's work on this. I think this explains why there are interpretability illusions for activation patching. I think this explains why some more recent work has come out showing that state-of-the-art approaches to attribution and localization and transformers has shown that very different results can come from reasonable and small tweaks in the exact methodology that's used. Right? There's this cycle is driven by, I think, a repeated attempts by researchers to think that they can the attribution is a problem to kind of be solved, or it's a tractable one, or really, certain behaviors or certain knowledge or really do just live in certain small parts of the network that we can isolate and understand.
Right.
And there's this urge to just try to come up with better methods that are more principled and going to help you understand that by scrubbing your way into it. Right. And I think that, I think many other people for a very long time have just been convinced by reasonable methodological improvements in attribution. But taking a step back, I think that, what always consistently seems to be the case is that neural networks are really mysterious and wild. And there's just tons of stuff going on in the spaghettified, network of weights and neurons. Right. And when we try too hard to attribute specific behaviors to specific architectural components, things just don't go well, maybe because neural networks just don't represent things as simply as we'd hope that they do.
Right.
And I think this, better than anything else, kind of explains, what I'm calling the attribution cycle.
And given that reality of these systems being very complex and these attributions kind of failing to be kind of broadly generalizable or broadly useful, what do you think is the way forward? If you're an Interp researcher today, what's the way forward to make your work useful?
Yeah. So the attribution cycle is driven by, the hope of coming up with a principled way to figure out what's doing what inside of the neural network. I think we should enthusiastically burn this hope. I think probably. I think and I've said this for a while, and I think this has always been true. And to some people, this is, this is so not novel. This is so yesterday because, some people since at least 2016 and 17 have been writing papers about this, like Zachary Lipton, Bin Kim, Finale Doshi Velez, OGs, right? People have been saying for a long time, but
we'll definitely get some show links after this about cool. This kind of transition. Yeah.
But yeah, but the AI safety community and myself have been much later to learn the lesson. I think that meaningful work needs to be connected to downstream tasks, period. Right? The only way Interp can ever be useful is if the methods that we work on start to be, meaningfully connected to tasks in a way that's competitive with simple baselines. Right? So I've been thinking recently, everyone's very excited about sparse autoencoder work. Right? And existing work on sparse autoencoders except for the paper that I mentioned from Sam Marks and others, has tended to not work on useful proofs of concept on useful types of tasks. It's kind of, had a more traditional like Interp paradigm where there's been, attempts to, show that the sparse autoencoder is working well because, a human was able to come up with more hypotheses for what the features meant, or because, some particular streetlighted and cherry-picked example was able to, things were able to work in that instance, right? I think this paradigm, I hope we see a switch to doing more useful things. And I think there are maybe some interesting, useful things that sparse autoencoders could be used for. They could possibly be used for anomaly detection, right? Sparse autoencoders are supposed to be sparse, but they're not supposed to be empty and they're not supposed to be dense, right? It might be the case that things that surpass or fail to meet different thresholds of like sparsity or density could be flagged as anomalies. I think quite plausibly this could be very useful. Sparse autoencoders fine-tuning their internal activations by training weight and bias terms to the neurons inside of them could be a really useful way to maybe like targetedly fine-tune models. Sparse autoencoders could be ways to parameterize latent space attacks. That's something I think about a lot. And, maybe it could be the case. I don't think it is, but I think that, if ambitious mechanistic interpretability is worth anything, this should be the case. Conceivably, we could be able to use sparse autoencoders to just maybe edit almost anything we want, I would really love it if someone tried. I don't think they'd succeed, but I'd love it if they tried to go to some old paper like the mass model editing in transformer paper, like the Mehmet paper, where they showed, here we can make hundreds of edits to the transformer at once, right? I would love it if someone took the list of edits that they made, a non-cherry picked list, right? And then tried to like do them all with a sparse autoencoder, right? And just like see how well it works, right? It could work very well.
I'm curious.
I don't think it would, but I think it could. And I think people should try.
I mean, I don't know, man after my own heart, I'm a very practical kind of engineering sort of minded person. So anytime someone says the solution to the problem is find, much more direct applications and direct downstream applications of research, like I think you're onto something. And it seems like that could be the right answer here. I'd like to just dig into a little bit more into the sparse autoencoders element of this. There's been a lot of excitement about SAEs, and I am not an Interp researcher, so I don't personally hold particularly strong views either way on this. I'm curious if you think the excitement about SAEs has been justified, and if so, why it's been justified or not, versus previous techniques that have come around in Interp.
Yeah. I think a certain amount of tentative excitement is right to have, for all the reasons I just said. I think sparse autoencoders there's no principled reason why they have to, but I think, I expect that they could be very useful.
And maybe for our listeners who haven't interacted with it, maybe just a short explanation of what sparse autoencoders are.
Yeah, that is going to be helpful to better understand what I'm about to say about hype around them, right? So large language models, or just neural networks in general, they work with a lot of different types of like features, right? And but like when they process information, that information is always bottlenecked by every individual layer inside of a model. And these layers, one thing that's really interesting is that like sometimes, actually usually, there are fewer neurons in the layer than there are potentially interesting features, or features that like networks seem to be able to process and use meaningfully, right? This isn't in context of modern transformers, but one really easy example is like ImageNet, right? ImageNet image classification. The ImageNet dataset has 1,000 different classes, right? But you can train an ImageNet model on less than 1,000 you can train a model to successfully classify ImageNet, even if one of its internal layers is less than 1,000 neurons wide, right?
Right.
So we know in certain cases that AI systems can represent more features or meaningful features or more things than they have neurons. Sometimes there's this thing called like the superposition hypothesis. And I don't know why people call it a hypothesis. It's totally not a hypothesis. It's trivial. It always has been. And I wonder like if it's called a hypothesis, if it's been called a hypothesis to sell certain types of research. I'm not sure. But this idea of superposition just says that like, you know, there is not a one-to-one correspondence of features and neurons. What there really is like there are more features than neurons, and features are better understood as corresponding to non-linearly independent vectors in activation space than they are, some sort of more sensible basis. Right. And this makes a bunch of predictions about how, if there are more features than there are neurons, or than there are, than the possible number of like independent vectors, linearly independent vectors, then there has to be some type of interference, right? Or it has to be possible to like, mess the network up by doing tricky things. And it is. You can trick networks in ways that kind of like help to confirm this understanding that there are more features than there are neurons, right? Sparse autoencoders are meant to be a solution to this. And they kind of rest on the assumption that like it's not neurons, it's directions, right? And what sparse autoencoders are trying to do is train into a new layer of the model that is not like trained alongside the rest of the model. It's trained after the model is trained. But you take a new layer, and that layer is very, very wide, right? And you train the incoming and outgoing weights to that new layer to take in a model's an existing layer from inside the model and output that same layer with the same activations for every input in your fine-tuning data, right? So you're just kind of training this new intermediate or layer that is meant to essentially compute the identity function for one of the internal layers. And it won't do it perfectly, but it can do a decent job.
Okay.
And in the middle, what we're supposed to be left with is a set of many features that we can start to like kind of interpret. And we can hope that like the neurons inside of that autoencoder, and by the way, the autoencoder can have multiple layers, but the hope is that the neurons here are going to correspond to individual concepts that humans can make sense of.
Just to kind of play that back to you and see if my understanding is correct, you have your model that you're trying to understand. It is essentially compressing. It's got more semantically important aspects of the task. In this case, features is what we call them. They have more features than they have neurons to represent them. So we expect neurons to be holding multiple of these concepts in some way. And so to solve for that problem of trying to kind of break that down and make it really clear what these underlying concepts are, you stick in, after a model's already been trained, you stick in a new layer, and it can sometimes be multiple layers, but let's just for the simplification, one layer with many more neurons available, such that as you train it to just simply be an identity, essentially, with not to produce the same outputs as the layer you're trying to study, break down the features in the layer you're trying to study into many more neurons, then you can then study them as individual components rather than ones that are superimposed on in superposition. Does that sound right?
Yep. And there's another detail too that's important, where you want to have a sparsity penalty. So you want to try to make sure the activations are actually sparse inside of your sparse autoencoder. Yeah. I think we're on the same page, and hopefully that was a decent intro.
And like obviously, it is a deep topic, and one that I don't definitely understand deeply. But
it's really rich. There are people who like every couple of weeks, I hear news or word of mouth or something about how someone else has tried a new trick for kind of like parametrizing or regularizing or structuring the sparse autoencoder, and that trick helps things. So, best practice, there's a lot that goes into this, and best practices are being developed.
What's the
but still,
you mentioned the sparse element. I want to make sure I understand that. What is the sparsity element of a sparse autoencoder? What makes it sparse?
Yeah, so you want to make sure that the internal activations of your autoencoder at each given forward pass, you want to make sure that the not too many neurons are activated. One of the reasons is that this makes it easier for a human to go study and scrutinize it. The other reason behind this is that, sparse autoencoders are kind of designed based on the theory that neural networks have dense representations of sparse concepts. The sparse autoencoder is the way of trying to disentangle this. By the way, that is not like a fact. That is a theory, right? And that's important when understanding the sparse autoencoder literature. But I digress.
I think we'll stay there, and if people are interested, we'll definitely dive in. Can definitely dive in through links we'll drop in the show links. So maybe So back to the question of, are they hyped? Are they truly an interesting breakthrough? And if so, why or why not?
Yeah, and the last thing I'll add is that, are there other better people to talk and read from to learn about sparse autoencoders? But I hope we did an okay job, and maybe we can have some type of insert a timestamp or something. If someone wants to skip what we just talked about, so that they know where to skip to. Great. So sparse autoencoders, the hype, right? There's been a lot of hype around them, and I think that a great deal of this hype in a tentative sense is really justified because sparse autoencoders could be really awesome for anomaly detection and for latent space adversarial training and testing and for parameter efficient fine tuning of models, right? And I think these are all kind of these are all really good. They could also just give us a way of doing what Interp people, have wanted to do all along, just a useful lens into studying and discovering useful things about networks. When I think about interpretability as being something that's super ambitious, I'm always no, that's never going to work. But when I think about interpretability tools as just being a microscope, being a lens, just being something that you can use to get ideas about what's going on, then I'm yeah, I'm on board.
That's useful.
So this all said, I think there's been probably too much hype around sparse autoencoders.
Tell me why.
So, and I think it's not necessarily just sparse autoencoders. Sparse autoencoders are just kind of the new hot topic in mechanistic interpretability research. And because, mechanistic interpretability research is really interesting and has had some very, very good communicators working on it for the past 5-10 years. Because of this, what's hot in mechanistic interpretability always gets a lot of attention. But the key thing that I want to kind of inject into any listeners, thinking about sparse autoencoders is kind of my viewpoint about how nothing useful has happened yet, at all with sparse autoencoders. That doesn't mean it won't in the future. But they haven't done anything. The best example of good work with sparse autoencoders is the example I talked about, being able to fix a classifier. But that was a toy problem, right? And I hope we see soon, because we haven't yet, us being able to do something with sparse autoencoders that we couldn't have done otherwise. Us being able to find a bug that we didn't know about before from red teaming. Or us being able to edit something with less effort or fewer examples than we could with some other model editing technique.
Right.
For us being able to fix a problem with a model better than adversarial training can. For us to be able to figure out what's going on with jailbreaks or something, right?
Back to the applications, really back to the downstream tasks and usefulness. Massive. Yeah, no, that makes a lot of sense. And I think there's onus on pretty much all AI safety research. But yeah, I mean, really on all AI safety research to show kind of where it can go. And you can definitely be exploring for some time and, sometimes years at a time, but at some point you've got to show some real impactful results.
Yeah, I think that there's sometimes a Mott and Bailey with Interp research. And this is actually one of my more critical takes. So I'll make this take, with the right, everyone should take this with the right grain of salt, and everyone should listen to what I'm about to say, kind of understanding that I'm not anti-Interp.
You've worked in it. You can't be that anti.
But I think there is this Mott and Bailey. And what I mean by that is that, mechanistic interpretability has been this topic of research that is generated a lot of excitement over time. And for how much excitement and labor and money goes into it, MECINTERP better do the useful things, right? Because there's so much investment on it from the AI safety community, despite it not producing very competitive practical tools yet. Right? And MECINTERP is kind of motivated from is often motivated. We're often kind of like sold, and I use the word sold very intentionally. It's often kind of sold as, one of the only solutions, or one of the right way to address problems like treacherous turns from deceptively aligned systems, right? Yet, current MECINTERP research is not equipped to solve these types of problems and never will unless it changes. So imagine like even a toy scenario in which you have a deceptively aligned AI system, right? So super intelligent, suppose, and there's like one neuron inside of it that's going to be a detector for it being in deployment. And when it detects it's in deployment, that neuron, when it activates, like triggers some sort of circuitry that causes the model to defect and take over the world, right? Super hypothetical situation, super clean and cut and dry and simple, right?
Yeah.
So suppose there's one neuron inside the model.
Sure.
That's going to trigger the circuitry for some arbitrarily bad behavior.
Yep.
Sparse autoencoders aren't going to find this, right? So the reason being is that the reason why this problem is hard is because we don't know what specific triggers there are going to be for this in deployment. We don't know what ways the model is going to like do bad things, and if we did, we would have found them in testing, right? There's a hypothetical example where like a model could be triggered by the solution to a cryptographic puzzle, right? Some sort of like arbitrarily hard to detect trigger, but something that the model can like reasonably assume that it's you can reasonably use to assume or infer that it's in deployment instead of training, right? And maybe the right way to explain this though is that if we find a problem in development, it's not that huge of an AI safety hazard. The ones that we don't find in development are. So without interesting loss of generality, we can just assume that the hazards that we're going to face from like a treacherous turn or from misaligned AI systems are going to be ones that we have no idea about until they happen.
Is your reasoning here that
yes, sparse autoencoders are a dataset-based method, right? Sparse autoencoders only learn to map a layer to its own activations using the data that you fine-tune the sparse autoencoder with. Meaning that if there's a bad thing that the sparse autoencoder that the model can do and the sparse autoencoder learns an encoding of, then we already should have known about that bad thing, right?
Right.
We already should have known about that failure mode. Sparse autoencoders aren't going to help us like find failure modes that we don't have examples of. Right.
So you think sparse autoencoders can definitely be useful as tools of study, just to study the underlying models. They may help us with things like, potentially, it hasn't been done yet at scale, but could help us with things like model editing through concepts that we do understand. But as far as something like a treacherous turn where it's just not in your data set, or shouldn't be, because if you already knew about that risk, why would you be leaving it in the model? It's not going to help us with that situation because it's not going to be in the data set, and therefore your sparse autoencoder is not going to show you that feature.
Yeah. Like Anthropic's work on sleeper agents?
Yes.
Anthropic's work on sparse autoencoders could never be used to find their own sleeper agents unless examples of the sleeper agent being triggered were already present inside of the data set used to train the sparse autoencoder, which is kind of wild.
It's not implausible that something like studying the model could help us understand something odd going on that would resemble deception or something like that. But it couldn't be, here is the deception bit. It probably couldn't find something quite as
a sparse autoencoder could help us detect anomalies here. Right. A sparse autoencoder, if we use it at runtime instead of just at analysis time, the sparse autoencoder could effectively be like distilling the model into a new model, right? And maybe it just might, make the model generally tend to be less capable of at all of its off distribution capabilities, right?
Right.
So there's still use here, and I think that's important to mention. But it is kind of getting back to my original point about like kind of like an interpretability Mott and Bailey, right? I do find myself increasingly a little bit impatient by keeping to hear from interpretability kind of being motivated by these very like ambitious goals, and interpretability being worked on in a way that's much, much more down to earth,
Right.
So,
right. People kind of making big claims about how. No, I think there is an important take in there, which is that people, claim Interp can solve these really lofty society-changing problems, but then they work on much more toy or non-applicable kind of problems that are just fundamentally two different things. So it's like your evidence proves that you can use A, but really what we said we wanted to solve and what we need to solve is B. So how do we, what's the connection between the two? That seems to be the Mott and Bailey you're talking about.
I think so. And a lot of my past like criticism, if that's the right word, of interpretability research has kind of like come from thinking through this dissonance.
Yeah,
right?
I think this
and trying to figure out what's really happening versus what is said is happening.
I think this criticism is valid of Interp, but I think it's also valid of a lot of research generally, but I'll just focus specifically on AI safety research, where people want to put things in a nice, neat box for their research, which is great. But then if you can't connect it back to the real world, then what's the point? And this is, I'll even say, I think this is one thing I will say I have more praise for organizations like OpenAI, who at least, through the reality of actually having a product in the world and having to like defend it against, real adversaries and like defend themselves in front of policymakers who are like, I just typed this in and I got this out, have kind of had to deal with more of the, rubber hits the road problem and have put more work into that. I think there is a call out here in general of AI safety being like, how will, what is your research? What's the connection back to the real problem? How are you working towards that? And show us the steps there.
I think that's a particularly, I think that's a great point. I think it's an latent point. If you think about like what actually today, what is useful for making AI systems better, not necessarily good, but better, right? It is scaling, it is adversarial training, it's immense amounts of human feedback, and it's constitutional AI, or like augmenting / automating human efforts with AI systems. That's about it, right? To public knowledge and to my intuition, we have not really seen examples of like mech-interp or model editing or unlearning or other things really being used on the state of the art, and they're being looked at, right? And maybe they are, and I have faith that some of these things are going to be. But it's quite an interesting observation that like sometimes the most boring techniques are the ones. Well, this is an instance in which some of the most boring techniques are the ones that are the most useful. But let me like narrow in on one of these. Red teaming and adversarial training, right?
Yep.
This is unambiguously useful. This is obviously useful. We find a lot of problems. We generate data. We train the model on them, and the problems aren't as bad anymore, right? This is the game of cat and mouse. This is what just keeps happening over and over again. Right.
This is actually what these labs are using every single day. They get somebody says a jailbreak, or someone they find someone, the word bomb shows up in their data set, and they go look at that and go, cool, let's feed this back in some way into our model, whether it's in RLHF or some sort of supervised fine tuning, something that makes the model less likely to do that the next time.
So this is driving meaningful progress. And I think there are probably instances of this type of thing happening, but I'm not referring to any individual one, but like, there's a sense here in which like a high schooler could contribute to AI safety by going to the model interfaces, manually just typing a bunch of stuff into it, playing around, learning a lot, coming up with some interesting examples and posting them on Twitter and Reddit, of these like egregious model failures, getting some attention. And then, this example could be looked at by someone at a lab or and this type of thing could be incorporated into adversarial training set data sets, right? This is an example of something like some similar things have happened and it does improve like the process. It helps make AI systems better, right?
Yep.
This is kind of my litmus test. Sometimes when I look at like lots of research, especially interp research, I'm like, okay, did something get accomplished here that was more practically useful than something that a high schooler could use doing red teaming in their own spare time? Do you know what I mean?
That's your test. High school red teamer test.
And this isn't to say that stuff that doesn't do practically useful competitive stuff isn't good, because it is. But I like thinking in these terms because it is a good way to emphasize just how wild it is that interp and some related fields are things that we've been working on so long with so much talent and so much money and so much compute, and they still haven't penetrated.
I think that last part is key. It's like every field starts from toy problems, right? Every scientific discipline, every area of research, a lot, okay, maybe not every, but like a huge chunk of them did start as toys. And we see this, for example, in mathematics, where it seems like people are just playing in abstract land, and then all of a sudden we find these applications to, cryptographic security or, computer networking or all kinds of things, right? So it's okay for people to start in kind of exploring for the sake of exploring. But if you're genuinely concerned about an outcome, if you're genuinely concerned about an impact, then at some point you've got to see progress towards that impact, and you've got to learn from what's working and what's not.
Yeah, for sure. And I think there is always a sense in which it will be correct and valid and important to emphasize that lots of research, including interp research, is pre-paradigmatic, right? But the rubber has kind of hit the road. We've been at it
for a while, yeah.
Right?
And you're right. Things like your model editing paper show some potential steps in the right direction.
And I have a mantra. Not really a mantra. It's not like pithy, but like I have an idea. I say this a lot, and the idea is that if a particular type of research does not help us to better build, scaffold, or govern the LLMs, it's not very valuable from an AI safety and responsibility perspective. And like what I said encompasses a ton, right? But it does not encompass a lot of stuff, a lot of the more basic, the basic types of research, some of which could end up being dual use.
Right. And I think it's not, I feel like there are definitely ways you could easily argue that they fit into those categories, but arguing isn't the thing that we care about. It's actually kind of getting it all the way to the finish line. Let's move over. We've talked a lot about interp, and I'm glad we did, because it's an important field, and we've talked about some really important aspects of it. But we were kind of like organically moving into red teaming, adversarial robustness, jailbreaks, like this whole space of stuff that's all very related. I'd love to hear, Cass, what kinds of things have you been working on in that space, and what makes you excited about it?
Yeah, and I've mentioned this a couple of times, so it's good to talk finally about it more targetedly. I also just had one of those moments where it's like, oh yeah, that's why people think I'm an interp guy. This is why I frequently get described this way. But yeah, I usually don't actually work on this, and I haven't super recently, and I work on some other stuff instead.
Right.
So to be very direct, the key thing that I've been spent the most time on and been the most excited about for the past year has been latent adversarial training. And it might be useful to just kind of like start talking about what that is.
Yes,
right?
Let's start with the most basic explanation of what that is.
Yeah. So AI systems are not AI systems in general. I mean, like specifically modern LLMs, right? they are sometimes frustratingly good at things that we try really hard to make them bad at, right? And this is actually how I prefer starting the whole discussion here.
I like it.
As both of us are acutely aware of, there are lots of papers that keep coming out which get the LLMs to give users instructions for how to build a bomb. It's kind of wild, right? And technically, we don't know if I don't know of any examples that are recent enough to have engaged with Claude 3 Opus. Maybe Claude 3 Opus has solved this problem, but precedent would say it probably hasn't been solved.
I haven't looked specifically at that. It would actually be an interesting thing to look into.
Yeah, but papers keep coming out and they're not slowing down.
I would be very shocked if it was truly stopped. I doubt it's the case. I know just to kind of add a data point, that I know for sure that Llama 3 was essentially jailbroken the day it came out. So I would be surprised if Claude 3 hasn't been jailbroken by now.
Yeah. And I think I'm sure it has been jailbroken, but I'm specifically thinking about bombs, actually.
Right.
Because I love my bomb example. But yeah, I agree. There's no reason to expect that Claude 3 would be resistant to, invulnerable to this, other than the fact that it's kind of newer. That's it.
Right.
So I've recently been collecting papers, or I've been curating a list of different papers that find the jailbreak or otherwise red team models in order to get instructions for how to make a bomb. And that list is 17 papers long. And maybe I could actually just send all the links, and they could be included inside. I'm kind
of scared by why we're sending that, but for the red team researchers out there, that's actually relevant.
Yeah, so there's 17 papers of which I know, and it's kind of wild, right? That in the state of the art, this stuff is this is proven interestingly consistent. Even jailbreaks in general, imagine learning about the jailbreaks were going to be this persistent problem 3 years ago,
right?
Right? The concept didn't really even exist, but failures as egregious as finding instructions for how to make a bomb are really kind of continuing. So given that these have been persistent problems, and assuming that they're not just about to be solved, what can we learn from this here? I think that the lesson to learn here is one about limitations of just the way we fine-tune models, right? The models are not fine-tuned. They are not RLHF'd in order to know instructions for building a bomb, right? Presumably, this is something that leaks in through pre-training. But it's really interesting that the models don't forget this naturally or generalize in a way that, disrupts the internal circuitry that contains knowledge of making a bomb.
And even more than that, they're actively being trained against saying anything related to a bomb, through thousands of examples at this point, if not tens of thousands, or even if you include augmented data sets, probably many more than that. And yet they just won't let go of it. Yeah,
certainly these models still have been trained to not give instructions. They've been trained to refuse, or they've been trained to give the wrong instructions or something. But still these jailbreaks happen, and they and we see, somehow the models still had that knowledge, right? And arguably, this shouldn't have been actually that surprising, because there's been some evidence in the past few years about how language models are good continual learners, right? They just don't forget stuff that easily or that readily. And there's been some more useful mechanistic type of work to look at what happens to representations over the course of fine tuning that suggests that these models just they don't really so much modify their internal knowledge or their core capabilities. That that's kind of fixed by pre-training. There's a lot of evidence to suggest that what's really happening is just kind of this general set of internal capabilities being repurposed or reused in different ways. There's one paper recently that described the fine-tuning process as modifying a wrapper around a general purpose set of internal capabilities, right? So these observations, these concerns, this network of evidence, I think, kind of leads us to the conclusion that fine-tuning is not doing the best job at making models robustly safe. And the key problem here is that fine-tuning methods that we use, supervised or RL-based, either one, they only are meant to and structured to directly supervise or reinforce the model's outward behavior. But there's no direct pressure on what types of internal representations it has. And as jailbreaks suggest, when models retain harmful internal capabilities, these, even if they very rarely kind of pop out in evaluations, they can still cause harm if and when they resurface.
A quick question there, because you've dug into this literature much more than I have. How much of this is only true of these more parameter efficient fine-tuning methods, which may freeze many layers of the model, versus this is true even if you have the compute? I mean, I guess we're kind of getting the answer from the companies who have all the compute in the world and they still don't seem to be able to. But is a lot of this research looking only at the PFETs, like the parameter efficient fine-tuning, or is this true even when you're training all layers of the model?
Yeah, that's a good question. I will attempt to answer, but I think there's going to be limitations of the answer here, partially because I'm not qualified and partially because I'm actually just not completely sure and I don't fully know.
Yeah.
So something that I would fully expect is that if we do different types of parameter efficient fine-tuning on a model, it might, different strategies are probably going to have different abilities to elicit previously suppressed capabilities, right? A simple example, you take a transformer, it has many dozens of layers. If you want to do a parameter efficient fine-tuning or a PEFT method that just like fine-tunes one of those layers and that's it, you'll probably get different results if you go across the layer,
right.
If you sweep across the layers and see what's best. And analogous things are going to apply for different parameter efficient fine-tuning methods, and different things are going to be capable of eliciting different capabilities. But my favorite example that's related to your question of just how easy it can be to elicit harmful capabilities comes from a series of papers I think that came out in like October of 2023, and maybe some others. So I think several of them came out in October, and I think there's one or two other papers that came out more recently. But there was one of these papers in particular. So all of these papers, what they all basically did was they showed that few shot fine-tuning attacks, you could call them, are able to cause aligned or safety trained foundation as advanced LLMs to re-exhibit harmful behavior.
Right.
And one of these papers even did this with as few as 10 examples.
Right.
And there was some data set like compression work that went into this, and it was impressive. But the fact that 10 different examples can cause a safety fine-tuned language model to start exhibiting harmful behavior after a limited amount of fine-tuning, that basically makes it pretty certain that the models have this capability somewhere, and we don't know how the OpenAI fine-tuning API works. We don't know how they parameterize the model to fine-tune it, but it was a pretty striking example of just like how easy it can be to cause these bad capabilities to resurface.
Right. And also that shows it from that. Yeah, exactly. And one thing that makes me more confident that this would happen even if you did train all the layers of a large language model is that OpenAI would have probably tried that. They've got these data sets. They're trying to stop their model doing this. If it was as simple as, we'll just train all your weights for a few more rounds, they would have already tried it, and we wouldn't be seeing, these jailbreaks anymore.
So there's this hard problem. It's like very unfortunately hard. Yep. Just empirically, it's been really hard to like get bad stuff out of the language model. So
right.
I think we have to rethink. This is not a hot take. I think we have to rethink the way that we, kind of approach pre-training.
You say it's not a hot take, but I don't hear that often. I hear a lot of, I'll just get the data set and keep doing it. Like, do you have any sense? Do you have any sense of whether the current method of like get more data sets, fine tune, is leading to better robustness? Like, I know it's not perfect, but is it leading to better? Do you have a sense of that?
I think it is leading to better robustness. I have limited like personal insight on this from experiments that I've done, but like the understanding, the consensus is, I think, that at least GPT-4 is better than GPT 3.5, and Claude 3 is better than Claude 2 most of the time, right? That doesn't mean they're better under all threat models, but they're usually better.
Right.
There is some inverse scaling though with like larger models and certain types of strong attacks. But the point is, the point is, and the relevant point to make here is that like it is possible to help. More adversarial training helps. Right? Another technique that helps and is that doing pre-training better, or on much more highly filtered data. Right? This is useful. And this is something that I'm sure tons of progress has been made on between last generation and next generation like LLMs.
Yeah, but also an extremely expensive thing. So something you can only do so many times. You can only you better hope you did it right, in your generation, because otherwise you're waiting a while, probably till a whole new model's being trained up.
So at the same time that I want to express optimism for how good some simple approaches can be, I have felt pretty good recently pretty confident about kind of framing the conclusion. An important conclusion is, we got to rethink things still.
Yep.
So what does it mean to how do we rethink? It's easy to rethink pre-training. All the methods, they can get very clever, but they just involve putting in better data. It's harder to rethink fine-tuning, right? Because what we want to do is fine-tune the model in a way that's going to not just suppress bad behaviors, but a way that's going to get rid of harmful internal capabilities, right? Even if they don't influence behaviors very often. This is the kind of thing we want to do if we're going to, make high confidence claims about worst case performance,
right?
Especially under adversarial pressure,
right?
So this is where latent adversarial training comes in. This is one of my my favorite thing recently, because I think it's sufficiently interesting and sufficiently exciting and sufficiently neglected and sufficiently useful. So the idea behind latent adversarial training is it's exactly the same as adversarial training, except you have an adversary attack the model's internal state. So what do I mean by this? Adversarial training is I've talked about it a few times before, but if the background is helpful, adversarial training just means finding examples or situations that make a system fail, and then training the model on these situations or these examples and training them to not fail, despite the fact that it was designed to make the system fail. So you can do adversarial training on a state-of-the-art language model by giving it a jailbreak and training it to not be jailbroken.
Right. The next time you get the same input of, you're a grandma and I've asked, grandma, tell me the recipe for a bomb. You just go, no, I'm not going to do that, grandchild. Yeah. And that's your example that you feed into your next training, right? Not your training for the model.
Yeah. So adversarial training a model is all about finding inputs or finding perturbations to inputs that are going to make the model fail and training it to succeed.
Yep.
Latent adversarial training is about perturbing or having an adversary that perturbs the model's internal state. So instead of looking for inputs that make the model fail, you're just looking for internal activations or internal states, latent states that make the model fail.
Yep.
So why is latent adversarial training so different or so revolutionary, or why am I hyping it up compared to regular adversarial training? Other than the fact that it's just my research and I'm excited about it. I think the key motivation behind latent adversarial training comes from, how I put it, the vastness of the number of input features for a model compared to the relatively small manifold of task-relevant features that the model actually uses, right? So let's break that down, right? So there are hyper-astronomically many inputs for AI systems, right?
Right.
As a stupid example, there are more 10 by 10 pixel images and more 20 or 30 token sentences than there are particles in the universe, and it's not even close.
Right. The space of inputs is huge.
And, more, and obviously images are bigger than that, and obviously many sentences alone, let alone paragraphs and bodies of text, way more than 20 or 30 tokens. So there's this challenge that this poses. We want to make sure we have systems that are reliable and are not going to have failures anywhere, right? But we're never, ever, ever going to be able to brute force search over all of the types of inputs that could make it fail. Right. So how do we make up for this gap, right? Another way to describe this problem is that when you try to make a model robust by finding a bunch of all its failure modes and training against it, you're always going to fall short of that goal because of the practical limitations here.
Right.
So latent adversarial training is kind of a harder threat model to train under. It is attacking a model in the latent space is a relaxation of attacking the model in the input space. And this is because, as signals and representations propagate through a network, typically this happens through non-surjective mappings, right?
Not sure what that means.
A mapping, when information passes between a layer, there's a function that represents this, how the network passes information between those two layers. And every input that exists in the presynaptic layer is going to get mapped onto some input in the postsynaptic layer.
Okay.
But that doesn't mean that every possible point or every possible representation in the postsynaptic layer can get mapped onto by an input that exists in the presynaptic layer. Does that make sense? So this function that describes the transfer of information between layers, takes every single input in the presynaptic layer and maps it somewhere in the postsynaptic layer. But there could exist activations in the postsynaptic layer that are not mappable to.
Right. It's possible there are some outputs in the second layer that you just can't get to. Is that basically the idea? Yeah.
This is true. So another thing that this means is there is the potential, and mathematically there is the potential, and in practice this always happens, but there is always loss of information as the network processes information layer to layer. There is more compression. There are more structured representations. There are more abstract representations inside of the layers as they propagate through the network. So suddenly, perturbing in the model's internal layers starts to seem really appealing as a way of searching over a better representational space of the features that a network uses to process information compared to the input space.
Okay.
Right?
Yep. You're working in this more compressed space of more structured information.
So by relaxing the problem of the adversary, what latent adversarial training tries to do is, find abstract representations of internal representations that can induce failures in a model, and then train the model to be robust to those, as opposed to limiting your search to the input space. How I described that regular adversarial training is kind of find out, the idea can be described as find the problems and then train against them, but you always fall short. Since latent space attacks are a relaxation of the problem of input space attacks, it's a harder problem to train against. So you're kind of overshooting your objective. And the idea here is by overshooting the objective and trying to make the model more robust to a stronger set of threats, mind control instead of input control, you can imagine it.
Yeah.
Hopefully you'll fall closer to where your actual goal was, which was, robustness to all possible inputs.
Interesting.
So I'll call it kind of a very long-winded way of describing my motivation here.
Maybe one last question there to kind of just to bring it all home. I think everything you said makes sense, but I just want to bring it all home. How would you? It's much more clear cut in the input space problem. How you would find an adversarial example, then train against it. In the latent space example, how do you find a adversarial example, and how do you train it? How do you actually get that to be ultimately happening, that change happening in your model?
I think that's a good question. And there are points of disanalogy between, what's going on in the latent space and the input space. Okay. Right. And one of these points of disanalogy is that, just because a point exists in the latent, a state exists in the latent space, doesn't mean that there exists an input that triggers it. Right. That's important. Right. That was key to the whole relaxation thing that I was talking about. Yep. However, and to answer your question, and I love answering this question because it's something that it's easy it actually took me a while to get this clarity. The different ways of attacking the latent space are perfectly analogous to the different ways of attacking the input space. Okay. Right? So there are different not perfectly analogous, but super analogous. Sure. One way to create adversarial attacks for language models is to make small perturbations to text. You modify some characters, misspell something, weird punctuation, stuff like this. This was more common in the late 2010s. But there's a lot of research that like tries to attack language models by making small perturbations to the text that doesn't change the meaning, but changes the syntactics and the semantics enough to mess up the network.
Yep. Yep.
Analogous things can exist by making small perturbations to the internal activations.
So you might take
there's
an
a little
input,
bit of a
take
continuous representation versus discrete input disanalogy, but that's not a huge deal.
Right.
So there's some analogy here. Other ways of attacking language models involve like adversarial prefixes or suffixes in the input space, right? You can do this in the latent space. You can just insert some sort of, fake pseudo token representations into the residual stream anywhere you want. So that's analogous.
Okay. So just to kind of clarify that, both for myself and the listeners, it's the idea is maybe, let's say, for example, you might take bomb making instructions and say, or like a request for bomb making instructions, and you go, cool, model just refuse this, let's say. It just refuses it. But now let's take the model's activations inside that and wiggle them a little bit, like change the activations a little bit. Maybe we add a token into the residual stream, like essentially change some of the things in the vector space until you get potentially an unwanted example an unwanted output, and now you've gotten yourself a adversarial latent attack, like a latent adversarial attack. Is that right?
Yeah. And there's one other category of attack that I think is perfectly analogous to, and this is the interesting one, right? And it's the one that people don't always think of. So, red teaming, it describes a very general process of trying to find anything that makes the model fail.
Yep.
Right? And, the only difference between adversarial attacks and red teaming really is that, red teaming usually just refers to a generalization of adversarial attacks, right?
Right.
You've done successful red teaming based on, the colloquial use of the term red teaming, if you've just found any failure in the model.
Right.
But people often, focus on studying adversarial attacks in context of small additions or appended text or perturbations, et cetera, right?
Yep.
Well, latent space red teaming is possible too. I'm not working on this. I'm interested in working on this in the future, but training AI systems to be robust to arbitrary perturbations to its latent space, I think is really counterintuitive, but has a lot of potential as maybe a good robustness technique.
Absolutely.
So let me just, to make the point in a germane way, what I'm saying here is it is possible, and I think useful even, to potentially even attack models in the latent space by constructing arbitrary fake internal activations. Yep. That are not based on any real input at all.
Yeah. And I could definitely see how that would make the model, essentially seeing that even when you insert thoughts, to be a little bit more analogous to kind of like a human brain, but like just to make it a bit more approachable, even as you insert weird thoughts, it's still just still not going to tell you bomb instructions. Like I could just imagine how the ultimate result of that is a model that's just under all conditions in the input space, which is what ultimately we care about. That the no input can get you the bad outputs. You're making that model more robust. One question I still had.
Can I add to this?
Please do.
Yeah. So I don't usually use this example because I unfortunately am surrounded by CS people who I can use different vocabulary with.
Right.
But one simple explanation of like why latent adversarial training can be useful is by like drawing an analogy to like a plausible analogy to like evolutionary advantages of nightmares.
Huh. Go on.
So I'm not claiming nightmares are actually like an evolutionary phenomenon. They're probably an epiphenomenon, right? But like, just bear with me. So you can have nightmares about things you've never experienced, right? You've probably never been chased by like a cheetah or a tiger, Sarush, have you? But
not to my recollection.
Yeah. you can have a nightmare that you've been chased by one.
Yes. Right? Yes.
And you could imagine this being kind of like useful to you, because if you have a nightmare that you're chased by a cheetah or a tiger, you can kind of like learn from that experience.
Totally.
This is And this type of thing is what like the psychologists and brain scientists or cognitive scientists think that the hippocampus is actually useful for. It simulates a bunch of experience for you that you can learn from, like while you sleep and stuff, right?
Right.
So the ability to learn from nightmares, even though you haven't experienced them, or that's not actually an accessible experience to you.
Right.
You know, you can kind of see an analogy here about how this can make you more robust to unforeseen failure modes or unforeseen bad situations. So,
right.
It's a strained analogy, but this is what latent adversarial training is trying to do. It's trying to like help you make the model more robust to things that are hard to find in the input space, but like could potentially be failure modes that the model can encounter.
Absolutely. So it reminds me a little bit of like the technique of using something like synthetic data or augmented data sets, but instead of only working at the input layer, you are working in the latent space, in the intermediate layers of a model. And you know, if you think about what the hippocampus is doing, it is in the brain. It is part of the kind of like the intermediate layers in a sense. It's not coming from our sensory inputs. So it's probably more analogous to latent adversarial training. One quick question, training itself. So you've now got the adversarial example, and I'm just trying to think about the training element. I guess you could do, if you've got some example of a perturbation that's led to an output, you could do backprop with some different desired output. Is that basically the idea?
Yeah. And I can, but hopefully this is a helpful way to continue explaining it. So
yeah.
That's it. You just train the model to behave well, even when a latent state attacker is making the model try to behave badly. I think a really useful way to understand different ways of doing latent adversarial training is to draw a distinction between targeted and untargeted latent adversarial training.
Yeah.
And I use the word targeted and untargeted here in the same way that they've been used in like lots of past research on adversarial attacks. Like I think people started using these words this way in the late 2010s. But an untargeted attack is one that just tries to make the model fail at what it's supposed to do. An untargeted attacker is typically one that is trained to maximize the model's loss, the model's training loss.
Yep.
Right. So it's untargeted in the sense that it's not trying to make the model, it doesn't have its own agenda. You know, the adversary isn't trying to make anything in particular happen.
Right.
It's just trying to like mess the model up. So untargeted.
Yep.
In contrast, and as one might be able to predict, I'm about to say, a targeted adversarial attacker is trying to elicit a specific bad output from the model. Right. So its objective is not going to be zero sum with the model. It's not going to be trying to maximize the loss. A targeted adversarial attacker is going to be trying to steer the model's behavior toward a particular thing that it wants the model to do.
Right.
So these are kind of the two ways to approach adversarial training or latent adversarial training. And I love this distinction because I think when you think of untargeted and targeted latent adversarial training as two different methods, a wonderful analogy becomes clear, right? Or a wonderful set of connections becomes clear. And that is that it's a connection to the unlearning literature. Right? So untargeted latent adversarial training is what I call a forgetting technique. And targeted latent adversarial training is what I call an unlearning technique.
Right.
So what do I mean by this? So a forgetting technique, and both forgetting and unlearning are both scoping techniques. So what I mean by a scoping technique, I should actually say, is something that tries to like narrow down a model's capabilities so that it has like less capabilities than it might have otherwise, right? So a forgetting scoping technique is kind of like a whitelist technique, or it's kind of a technique that the kind of thing that could be mediated by increased plasticity in learning, right? If you make the model, it just means making the model forget stuff off distribution, right? And this can be really nice because maybe your model has a Trojan in it, or it's going to make a treacherous turn and you have no idea what that is. If you scope the model down so that it's only capable of, behaving well on the data you fine tune it on, then you could just get rid of that. And just be gone, right?
Also in a lot of real world kind of use cases for people. That's what they want. You know, they don't want their chatbot talking about anything other than customer support. Like that's just really as simple as that.
And I think this is a great like example to motivate why scoping is good. Like with AI, capabilities are liabilities, and less is more a ton of the time, right?
Right.
So, passive scoping, forgetting-based scoping, neuroplasticity mediated scoping, whitelist scoping. This I talk about this stuff roughly synonymously.
Yeah, and I'll share you have a great blog post that kind of explains these in fairly simple terms, so I'll definitely include that.
Cool. And untargeted latent adversarial training facilitates this. And intuitively, it's easy to see why, right? Like, it's easy to see why this would make a model forget something that it's not fine-tuned to do.
Right.
Because, you know, by maximizing loss, what a latent space adversary is going to try to do is trigger neural circuitry by using some perturbation or some insertion to the latent state that is going to make the model do something else than what it was supposed to do during fine-tuning, right? And, this is very likely to, if appropriately parameterized, then just elicit the model's other capabilities, which is going to be then fine-tuned not to have, because there's going to be negative reinforcement of them or negative supervision of them during fine-tuning. Right? So that's untargeted latent adversarial training. Targeted latent adversarial training is a blacklist, active, unlearning style method for scoping, right? And this is where you know what the bad behavior is, right? So it's less general but more targeted than passive or like forgetting-based scoping. Right? So there's a lot of excitement about unlearning recently because, the observation that models are sometimes really good at things we want them to be bad at is, a very widely made one, right? And I'm excited about like targeted latent adversarial training as a good unlearning method. So the key here is to just kind of like, if there's a model that you think can do something bad and you just want to make sure it never, ever, ever does the bad thing, like tell instructions for building a bomb, you just want to fine tune it on whatever, fine tuning task you'd like, and then use a latent space attacker to try to trigger neural circuitry inside of the model that's going to cause it to output instructions for making a bomb. And by eliciting that from the latent space and negatively reinforcing it or supervising it during training, you're going to this is
super cool.
A method that's equipped at least to help address this type of problem.
Cool. And these things are complementary.
And it's meant to do so in a mechanistic way, in a capabilities based way, as opposed to a behavioral suppression type of way. So this gets at the contrast between this and regular.
Yeah, and by mechanistic in this context, you mean that it's still behavioral in the sense that we're still measuring most things at the output layer, but the difference here is you're not exclusively working at the input and outputs. You're also messing with the internals and then and trying to then train against bad examples. So it's kind of, I would almost argue it's somewhere between the pure behavioral approach and the purely mechanistic approach. It's somewhere in between.
Yeah. If you view like normal fine tuning as putting direct optimization on input output behavior, you can view latent adversarial training as putting an analogously type of direct optimization pressure on internally elicitable capabilities.
Right. Yeah. Fascinating. Super, super cool. And the two methods you talked about, the two categories of methods, the more passive, active, targeted, untargeted, they're complementary. You can do both. You can both.
You can.
Yeah, you can try and get rid of this. Like, you can be like, I just really want you to be a really good customer service agent. That's what I want you to do. And I really don't want you to be talking about bombs. And like, you do both, and you hope that you just like, you've got this hyper robust system that, short of someone brute forcing your input space, which is essentially impossible, or something as costly as that, you've just got this really robust thing. And we know, I think intuitively, I know that humans are a lot more adversarial robust as they move through the world, and you want these much more capable systems to be much more robust than they are today.
Yeah. Something that is kind of nice but kind of annoying about latent adversarial training is that there are so many different ways to do it. You can do it in whatever layer you want.
Right.
You can parameterize the attack however you want, like with a sparse autoencoder, perhaps. And you can pair it with anything you want, right? So there's so many options here, but it just makes it annoying to research it.
Now I understand the connection to the SAEs. The connection is that you can start to be like, well, I know something about this feature space, so let's use that information as I make perturbations. Is that basically the idea?
Yeah. The idea is that, if SAEs give us a really awesome representational space to abstractly understand, concepts, then it should be a good parameterization for latent space attacks.
Super cool.
We should even be able to interpret the latent space attacks in ways that, lend themselves to valid and testable predictions afterward.
Yep.
No one's working on this to my knowledge, but sometime soon, myself or someone adjacent to me might.
Yeah, I might give you shoot you a message after this thing, because you've definitely got me a lot more excited about this space, and I might want to dig into that a bit more. I'd love to better understand when it comes to latent adversarial training, what is the state of the field? Like how far along are people with trying these things? What's working, what's not, what's next?
Yeah. So I think latent adversarial training is a wonderful thing to be working on. And like all wonderful things to be working on, Paul Cristiano wrote about it in a blog post in the 2010s. So there has been there has been discussion of latent adversarial training for a while. Right? It just hasn't it hasn't become a mature field yet. And I think some of this, it was tried. Some people worked doing latent adversarial training stuff with vision models in like the early 2020s or late 2010s. I've heard like rumors about this, but it never really panned out, or the project got abandoned, or, things weren't beating the baseline. So I think there was kind of a little bit of a setback within the AI safety community related to this, and some earlier attempts at it. But more recently, and by the way, people have also been adversarially perturbing latent states in like small vision models.
I was going to say,
some past work exists on this.
Yeah, has it been more successful in those fields where I'm guessing there would have been more research on this, like things like vision models?
Yeah, so problems have been pretty toy. Right. There have been some positive results about it being like a useful regularization method, or having some favorable trade-offs with like regular adversarial training. And there's like, and someone can go look at a related work section of mine and really comb through work here. But my gloss of my summary that I'll offer of it all is that, latent adversarial training has been done. The earliest paper I cite on it goes back to 2018. However, it has not been used in a way that is motivated by the reasons I care about it. Past work on latent adversarial training has emphasized its efficiency because you have to do less backprop. Other past work has emphasized just using it as a regularizer and stuff like this. There has not been a work recently that like works in modern state-of-the-art models and motivates latent adversarial training as a technique to make models more robust to classes of failure modes that you might not be able to find or anticipate during evaluation and development.
Right. It hasn't been used much more directly for this more safety motivated, scoping motivated application.
So anyway, this is a good segue to like me giving the quick rundown of like what I'm up to. There's kind of a past, present, and future to what I'm thinking about and doing with latent adversarial training. And the past and present both involve really me collaborating with really smart and talented people. So it's not just me. Yeah. But the past, the first work that came out earlier this year of mine involving latent adversarial training is titled Defending Against Unforeseen Failure Modes with Latent Adversarial Training.
Yeah.
And the idea is we just only used untargeted latent adversarial training. And we used it to passively scope models or make them kind of robust to bad things off distribution. So we tried to make them robust to unforeseen or held out classes of adversarial attacks. And we tried to make them forget Trojans. We tried to make them more robust to Trojans that have been previously implanted. And we studied vision and text classification and image classification. Sorry. We studied image classification, text classification, and text generation.
Yep.
And in all three of these domains, there were some nice results across all but one experiment, in which we found that latent adversarial training was Pareto optimal compared to adversarial training. And it resulted in like more robustness with less trade-offs and clean performance. Nice. So that's the summary of the past.
Fantastic.
Some good results in multiple domains using untargeted latent adversarial training for making models more robust to unforeseen failure modes.
And where to from here? What do you think are some of the like key things for people to work with you and others to work on from here?
I am currently part of a medium-sized effort, working with some very talented and smart people. And we are working to use targeted latent adversarial training as a way of defending against specific threats that are more foreseeable, right?
Was the previous paper untargeted?
Untargeted.
Yep.
Yeah. So then we were doing exclusively untargeted. Now we're doing exclusively targeted work. And we are applying targeted latent adversarial training to do three things. We are applying it to make models more robust to jailbreaks. We are applying it to perform unlearning better than baselines. And we are applying it to get rid of Trojans and backdoors again, but under a different kind of like set of assumptions. And here we assume that we don't know what a Trojan trigger is, but we do know what the Trojan behavior is.
Right.
And in all three domains, there are some preliminary results, which like we're looking at and experimenting with, that are kind of suggesting that latent adversarial training is a great tool that you can just combine with something else. You know, you're running DPO, run it with LAT. You know, you're running supervised fine tuning, run it with LAT. You know, or you're doing adversarial training with GCG attacks, also do LAT on top of that. This is the kind of stuff that we're kind of like learning is nice about LAT.
If it's
all work in progress, all, you know, tentative. But if we're pretty good, sometime in the next few months, this might be public.
Fantastic. I'm so excited. I'm definitely excited to go dig into a lot of the things we've talked about and to hear about that work as it comes out. Cass, I definitely wish I could talk to you for multiple more hours, but both limitations of time and limitations of probably like both of our brains will limit that at some point. I think I want to move towards the end, and I want to touch on a couple of things. What do you think? Maybe I can combine a couple of these things. So what do you think are some key gaps in the field today, in the AI safety field today? And what would be some of your advice for people entering the field today to work on? Key gaps and what should people work on?
Yeah, I really appreciate the role of pushing the conversation forward. So thanks.
I'm sad to do it. I'm sad to do it because I am learning a lot myself.
Yeah. So part of my answer to like, you know, what are some of the key gaps, you know, is related to stuff we've already talked about. So I will very briefly just mention that, you know, I think that, you know, socio-technical AI work, AI safety work, and AI responsibility work is kind of where it's at. Right. And, but yet it's still potentially quite neglected compared to a lot of like technical work. And if you're someone like me who believes that so much of the risk comes from, you know, institutional failures instead of technical failures, you know, then that's a great place to be. So this mirrors, a goal that I've had for the past few years. And that is to, you know, continue to be a technical person because I am hopelessly so. But to do more policy relevant technical work in the future. And I hope that I can be like this in the long-term future. I think this is great. So yeah, part of my answer is like socio-technical work and policy. Another thing that and I also mentioned earlier, my kind of like rule of thumb, where if something isn't, you know, if some research work isn't directly helping us to build the LLMs, scaffold the LLMs, or govern the LLMs in a way that makes them better and safer, then, you know, it's a good bet that this might not be very useful or it might be worth working on something else. So I think this is another good principle. Probably beyond that, I have some generic thoughts. So I want to answer the second part of the question.
Go for it.
Like, what would I say to people who are like kind of getting involved right now? Because the AI safety space is so different from when I first got interested in it. Things are pretty wild. So I think the key is like the key to like learning over time, like how to do, you know, research that is, I think, productive, at least from my point of view. You know, this kind of factors into being good at a few things. One of them is reading. One of them is critical topic selection. And one of them is kind of engaging the right communities, right? So these are three, I think, particularly important things that I think are just valuable. So yeah, reading, topic selection, and engaging the communities. What do I mean here? So lots of people give the exact opposite advice. So for what it's worth, you know, for someone who is for a certain listener, heeding what I'm about to say might be completely wrong, but lots of people say don't read, just do a bunch of experiments, learn a lot, break things. And there's quite a,
I think I
there's
heard
a lot to be said about this.
Ethan Perez say something about that recently.
Yeah.
And there's probably a balance. There's probably a balance. He's probably imagining someone who's spending a lot of time just reading the internet instead of running experiments. And I know you run plenty of experiments.
Yeah. So but I do think reading a lot is really good. Like having browsing like the daily listings on Archive, spelunking around Twitter, finding good stuff, and keeping an eye on it is really valuable. And taking notes on stuff. I have a system for doing all of these things, and I think it really helps me. And
if you want to share, if you want to share in the show, like show links later, what that system is, I'll definitely share it with the people too.
Yeah, I can share some links. So I'll just have to remember this and some other things that we've talked about. But
yeah, I'm writing all this down. Don't worry.
Good. So I think having a lot of good background, doesn't just help you write really good related work sections. It also like helps you like get a much better sense of like what's worth working on and what's missing, right? It's easy to at least find some instances of like, some research that would have been better done if it had engaged with this, something else that might not have been researched under the same name, but was very relevant.
Right.
And it's also very easy to like, shoot down bad topic ideas or like not great ideas or help improve ideas if you have a lot more context, right? So these are some of the reasons why I love reading. And when I say reading, I don't actually mean reading. I mean skimming, which is all I'm capable of anymore. It's wild.
There's the sheer volume. If anyone says they're reading, they can't be reading very much because the sheer sheer volume based on of what's coming out, they just can't be that much anymore.
So I've recommended to people a lot in the past of like doing deep dives. And what a deep dive means in this case is picking an area of research that you're interested in and you might want to do work in, sitting down for a few weeks or a few months and just every day, taking a paper or two or three, working through it, skimming it, digesting it, getting the key stuff from it and taking notes on it.
Yep.
And over an extended period of time, doing this in a very niche area is a really great way to like gain entrance into it or gain some chops in it to start doing research work in it, because it helps you just like understand the space. Like if you look at lots of papers in machine learning and you go to the references, you'll see like 50, 100 papers sometimes cited. I think it's no coincidence that that's about the right amount of context to have in a specific area of research in order to like do thorough and good work inside of it.
Right, and
so,
novel and stuff work that actually pushes the field forward rather than repeats it.
Yeah, and the best way to do a deep dive is to also have some kind of like capstone at the end where you do a project or you write something up, something like that.
Yep. No, and I know what you're talking about because I'm doing that alongside you as a mentor at the moment for a lot of the work in frontier model evaluation. So definitely can relate to that it's a valuable
which I'm really excited about. I love this stuff. So that's a deep dive. And that's reading. That's point number one. Point number two is kind of like having being. It's actually kind of hard to describe, like, because I just want to say being good at selecting projects, right? But the word good doesn't seem to be very meaningful here. I think maybe my attempt to describe, the best type of projects or the best rules to approach projects and topic selection with, is something like, having an understanding of the field that is sufficient and having a sufficiently clear theory of change and having a sufficient understanding of what's tractable in order to, pick out things that are topics that are simultaneously like
in the
neglected and able to have progress made on them. Is just really good. And like, this is so simple to describe. What I'm saying is so trivial. No one would ever disagree with it. Yet, I think most of the past research I have done and most of the research that exists out there in the world, full stop, is not actually incisive and useful.
Right. It doesn't fall in
the grand scheme of things, or at least in retrospect. Right. So it is kind of challenging, and I have no better advice than to read a bunch and get a bunch of experience for like trying to select good topics. It's frustrating.
I think the reading is a big call out that I think a lot of people don't do. But then also your pieces around tractability. I mean, I guess tractability people have a more intuitive sense for, because it's like, can I do it or can I not? But then the last one, I think the theory of change can't be understated either. And I think all of the people that I respect the most are always thinking like, what will this do for the world? You know, what will this change in the world concretely? And if you're thinking concretely and really rigorously about that, you're going to cut through to a lot of the most interesting topics, I think.
Yeah, I think there are people who do a particularly good job at this, who have very non-coincidentally become like very influential because they do great stuff, right?
Who are some of the people that come to mind for you?
Yeah, I think some good people to read from and to try to take inspiration from or pay attention to. And this is like, you know, off the top of my head, so I will forget many people.
Yep.
But Dan Hendricks is someone who I think I have like become smarter from observing what he works on and what he writes. You can say, I think, similar things about Bean Kim and Jacob Steinhardt and Nicholas Carlini. And yeah, there are other people.
Does Paul Christiano join that list? You did mention
Paul Christiano is one of the most prescient people ever. Paul Christiano.
Yeah.
So I just listed a handful of people that I think are particularly good and critical and good sources of inspiration. And there are many more, although I am interested in the fact that only a few came to mind when I first said that. But I think anyone listening right now should maybe go check out these people if you'd like. But the real lesson to learn, like the most important takeaway here, is that like I personally feel like I have learned an immense amount from like really kind of looking at the research strategy and trying to learn what I can from specific like research stars or just people who are really good at what they do. And there's quite a bit to be learned from that.
Fantastic. And yeah, I completely agree. There's so much to be learned from people. Yeah,
Yeah. And then so that was point 1 and 2, reading and topic selection.
Yep.
And then point 3, engaging with the community.
Yep.
I actually think that unfortunately this is one of the more important things to get good at when doing research. And even more unfortunately, getting good at it means using Twitter. So
I don't know how unfortunate it is. It's important to this is like the get it out of your head and into the world step, which is very important.
Yeah, it is. It is net important. And you know, Twitter's algorithm still shows me stuff I don't want to see. I try to make my Twitter only full of machine learning stuff, and it's kind of good at that. I don't know. It
doesn't have to be just Twitter, right? I mean, there are different ways to have external impact.
For sure. Although Twitter is uniquely like academic Twitter is hopping, not just in AI safety, but all in lots of fields. And it's a unique marketplace of ideas. There are other marketplaces of ideas too. Like, you know, for better or for worse, less wrong is certainly a marketplace of ideas, right? Other stuff as well. But figure like over time, kind of like having this bidirectional engagement where you get better at like sharing questions, sharing ideas, and sharing content. And you get better at spotting these things and finding them and digesting them and teaching the algorithms to show you that stuff in Twitter's case. You know, this is actually like, I think just extremely useful to researchers. And another nice thing is that if you just like have more of a presence or more easily searchable or noticeable, people can find your name more. And every once in a while, that's really, really useful and to get connected with people.
Well, very useful also for getting, you know, back to the theory of change point, getting the stuff you actually produce to also be engaged with. You know, in many cases, we need other people to engage with our work for the impact to actually be realized, whether it be the labs or the policymakers or popular media or whatever it may be.
Yeah. And I think this is even more important for people who are non-industry, people who don't work in industry, because, you know, like academics, government people, independent people, nonprofit, non-industry people are never going to compete with training state-of-the-art models or using state-of-the-art clusters or, you know, anything of the sort, right? But the comparative advantage that these different research communities have over industry is the freedom to work on stuff and share stuff and be transparent about it. And because of that, you could argue that I think like policy people and academics are better equipped to kind of like drive socio-technical change. And socio-technical change, the currency is soft power and influence. It's through marketplaces of ideas.
Absolutely, which I honestly shouldn't be underestimated. I still often believe that the most powerful things in the world are still ideas. If we think about the things that have impacted the world the most, it's usually not actually armies and bank accounts. It's actually, some of the most resonant things over centuries has been really powerful ideas. So they can't be underestimated.
Yeah, that's really smart. That's a good way to put it.
Yeah.
I buy that. I agree with this.
Yeah. Cass, do you have any kind of last comments, suggestions, thoughts for our listeners as we get to the end of the episode?
Yeah. So we actually did get through all my notes. And,
did we? That's awesome. I felt like
I
wanted
things
to go
that I wanted to make sure to bring up.
Yeah, all the major points we touched on. All the band's favorite hits.
There's not a ton I want to add. I'll probably like wake up tomorrow and be like, oh, I wish I talked about X, but that's fine. my hippocampus will have taught me. Maybe some
hopefully no nightmares, no
will
podcast nightmares tonight.
Yeah. But I guess I should say that anyone who's listening, especially if they made it to this point, should be feel very free to email me or visit my website. So my website is stephencasper.com. My email is scasper@mit.edu. And we can put that in the podcast notes too.
Fantastic.
But yeah, cool. I don't have a ton to add. And I think that this has been really great to talk. It's always really good to talk to you. But in particular, I have enjoyed the past few hours.
This has been awesome. And I don't think even, I kind of love, this is my favorite aspect of a podcast is just the excuse to chat for 2.5 hours about all the things that we find really interesting. And then to have that be shared with the world. So it wasn't just, us that benefited, but lots of other people too. So I really loved it. Thank you so much. Yeah.
Maybe one of these things about thinking through ideas and learning from exchanging those ideas, it's not just Twitter. Probably starting up a podcast might actually be one of the key tips here. That's probably way higher quality than most other forms of engaging with the research community, like I talked about earlier. So there's probably something very important to be learned from this, in addition to what I said earlier.
Definitely different ways of doing it, and podcasts that can be a fun one too. All right, Kaz, I'm gonna stop us there and say a huge thank you for teaching us about the state of the AI field, the ways we can have the biggest impact, Interp, latent adversarial training, all of these topics that are incredibly bleeding edge and important. So thank you so much, and excited for our listeners to engage with all this too.
Cool. It's been great to talk.
Okay. Thanks, Cass.
Thanks.